Hey everybody, this is Jason. I am here with Alison and Leo Saraceno. And today we have some fun and exciting clips for you and some discussion around biophysics and economics and Michael
Electrical
Levan,
circuit,
electrical circuits.
environmental templating.
Yeah. There,
Alison co-ops Jason's intro.
there's a no, that's good. It's hard because it's not like one subject. It's not just like one topic. And so we can actually talk a little bit about that too, where this thing keeps expanding and it's expanding it, but it's all connected, you know. So
That's my forte.
exactly. You're pretty good at it, Allison. But I mean, I think this kind of started with looking at some clips from Michael Levan. And do you want to just real quick, Allison, just kind of who's Michael Levan and kind of why is he important?
Well, so I pulled a bunch of clips from Michael Levan a while back, like a couple months ago, maybe even. And he's at Tufts, but he's also connected with like the WIS Institute. And his focus is on essentially like decentralized intelligence and intelligence of life itself at a cellular level, and looking at bioelectricity and its impact on embryology, and embryology not just meaning like embryos that make babies, but like how cells divide and become tissues and organs, and a lot of it feeds into regenerative medicine. But he also was part of the team at Tufts that developed those xenobots, which were using certain kinds of frog cells and genetic algorithms to create essentially quote unquote living robots. Sort of this new kinds of synthetic biology that creates Frankenstein type of life. But he's pretty straightforward about it. And I think these concepts, and we've talked about it a little bit in the past, we're living in a world of information and curated stories. And so most of the stories right now are about, generalized artificial intelligence, or they're about, genetic engineering and bioweapons and various things. And there's not a lot of focus on the stuff that Levan's doing, which I think is actually really interesting, has really complex implications on decentralization, intelligence, and electricity, and how that relates to stuff that, is really Leo's forte, around the Web3 and the blockchain and the ledger systems. So I put together a bunch of clips for that, and I think I might have talked about a few, and then of course we never got to all of them. And then someone alerted me to this talk with Lex Friedman of Neri Oxman. And so Neri Oxman is in the same sphere as Levan, and she came out of the MIT Media Lab, Mediated Matter Group, and then she just started her own company, and she happens to be in a second marriage with a billionaire hedge fund manager who's investing in synthetic biology, educational technology, and real estate development, mixed use real estate.
Planned communities.
And planned communities, yeah. So there is this interface between her ideas of mediated program matter, how it interfaces with Levan, and then I think these broader implications for computational aspects of society and biology. So I don't know. You have thoughts, Leo?
Yeah, I mean, so with specifically Michael Levan, I think especially once we get into the clips, he's really interested in philosophy of mind, but what he's doing is really hardcore engineering. He's a computer scientist, or has a computer science background, and he also went to Harvard Medical School and did his PhD there, I believe. And it's the Weiss Institute, I believe it's how it's pronounced, at Harvard.
Okay. WISS.
WISS, yep. And his big focus is on collective intelligence and bioelectricity, and the main kind of one of the main sticking points being that there is no single reduced intelligence that you can point to. All intelligence is collective intelligence, and then the way that he thinks that the way that you can really find that is in studying the like like the large scale anatomy and organ development, and like those how cells come together to make these larger structures, like with regularity and reliability, and then is doing a lot of engineering around kind of that electrical organizational process around embryos, and is doing a lot of really crazy stuff. He kind of he like puts it out really clearly, so it's a good example of like what's going on. And it's kind of interesting too, because I remember, do you remember Robert Becker, the
body electric
doctor? Yeah, so
Yeah.
it's really like he was a Air Force surgeon in the 70s who was really into bioelectricity and regeneration and stuff on salamanders, and pretty much like the same exact research as this. And like Levan uses a lot of the same language he does, and it's not, I guess what I'm saying is it's not this isn't like exactly brand new science, and it's something that has been worked on for at least the 70s. And
But they probably have
bioelectricity
the
for
computing
there's a
power
big
now.
long history for that. Yeah, that's like a big difference too. Yeah, the extent that they're using AI for like, especially because when you'll get into a lot of it for managing the like engineering the bioelectricities on changing the ion channels, so using drugs and other means to like turn off or make new like ion channels on cells in order to affect the bioelectrical organization of them. And yeah.
Well, and even like templating, like some of the stuff they were doing with the xenobots, that they would program like an outcome that they wanted and then run a pattern against all the different ways to organize the matter, this mediated matter, which is kind of Oxman's shtick, to get to an outcome that they want, which is some sort of life form that fulfills a certain objective, life form, I guess, air quotes on that. And so it's computational biology. But it's a lot of times I think it's framed as like drug development or precision medicine or something. But these xenobots are like literally little crumbly critter things that roll around in a petri dish. It's not something as abstract as like, some injectable or some, pharmaceutical program or some, electric medicine thing. It's literally like a critter. And the fact that we're not having these broader ethical conversations of like, hey, Michael, like, it seems a little Frankenstein-like, and then we've got his image of from his lab, which Leo, you pointed out would be a good starting point to talk about, which literally features a centaur, and it's hard to kind of see, but it looks like they've like lifted open the brain space of the human part, and they're looking in there because, again, mind is something he's interested in, intelligence and electricity, but also like where is mind and what are new kinds of minds that are coming into the world that he and Neri and their crew are planning to introduce us to.
Well, as far as like he was talking about the slime mold and putting in little, like little balls or whatever. I forgot what they were, but they were really tiny, where they could track where stuff went, and they could open and close circuits to, like sometimes it would go left, sometimes it would go this way or whatever, and they're like, oh, we can actually steer what this is, and we can create kind of like we can actually manufacture computation through that, turning avenues on and off, within the slime mold.
Well, and I just want to sort of open up too, because there's still this question of like, why? Like what? So like, I think Levan would say like the surface story is like, oh, I have this company, by the way, and we're trying to figure out how to regenerate a leg on somebody who's dropped their leg or whatever. Like, and so like his why would be like, hey, I've got a company and we'd like to regrow your leg. And, that's the surface level story why. But ultimately, like, there's always like several other layers of stories back. And it seems to me that the larger why is using, as you said, biological systems and social systems to do some sort of post-Moore's law computation. And that the new technology, as we move into like light-based and frequency-based and, optics and photonics, and is using biology as a node in the computational system, both like at a tiny scale and at a macro, at the micro and at the macro. And so swarm intelligence is a huge aspect of this. And I've been, going back and forth with Steffers in the map, and we're not going to probably get around to talking a lot about that. But the nanotechnology is also part of like that integration of our biology with computational artificial systems towards that steering. But the steering is, I believe, about problem solving, pattern recognition, some aspect that we may be involved in or participants in that we don't even fully understand what we're a part of. And so like beyond the weirdness of like, are we doing Frankenstein xenobots? Is that how we're normally doing things these days? We're going to invent all kinds of chimeras and centaurs and other creatures. Is that, are we agreeing to collectively participate in a collective computing program that we don't actually understand what the task list is?
When I think too with him, when you watch his talks, you might think, oh, he's just talking about cellular biology, or he may just be talking about some sort of like process that they're studying and trying to manipulate, like on a smaller scale. But you don't necessarily incorporate these ideas into like the social sciences and economics, and so that's the bridge that I'm interested in kind of talking about, the bridge between what appears to be just like a scientific study of like how do we how can we grow another arm or something, how that ties in with how do we steer and shape culture and steer and shape people and steer and shape through economic things. And another thing he talked about, which is what's interesting, was he was talking about hydraulic computation, which I hadn't really thought about that within the slime mold, because it was the closing off and shutting off of these.
Fluid dynamics is a big part of all of this, and also like swarm and crowd management, crowd control is part of the fluid dynamics equations. So can we open up?
Yeah, I guess we can start, but yeah.
So can we look at the map real quick, Jason, before we talk about the image?
And real quick too, did you want to say something about the Kelpius cave and Nephili?
Oh, sure. Well, so I guess what and this is something we're not going to have a chance to get into too deeply in this conversation, but there are aspects, I think, of this computational program. Some of it involves harnessing our cellular processes into creating, as bioreactors or as different sort of processing facilities, like in a material state. But then there's other aspects of it that I actually are more linked to things like, in my opinion, like psychodrama or like collective participation in game, extended reality, game mediated spectacles that have to do with archetypes and stories and myth. And this guy, I think Stephen Steffers had alerted me to his work. And so he's proposing that somehow we're going to have like a collective, communal healing through extended reality video games by participating as archetypes. And a lot of this interfaces with Greek mythology. And, you might kind of just slough it off as like, oh, that's just a weird thing. But, as I mentioned, I finished Neil Stephenson's Cryptonomicon, and there's like a key aspect, there's a key exchange in one of the pivotal scenes where he's actually talking about specifically Greek mythology and mythos carrying forward into like these archetypes into current reality. And they were comparing like Athena and Ares, like the god, like the war, different ways of fighting a war, and that Athena was cleverness and Ares was brutality, and that the hackers were backers of Athena, which was sort of the trickster cleverness. But there's so many overlaps of this, like it's hard to discount and just be like, oh, that's crazy talk, because we know that Jacob Moreno, an early person who was doing sociometrics and psychodrama, like was connected with MK Ultra and all of that. He ran his own sanitarium. Like they've been interested in this for a long time. So it's at these different levels, the cellular level and then the mythic level. And so when you see that Levan's featuring a centaur on his lab page, And again, it is this image for people who are listening and not seeing it. To me, it evokes a story. Like you've been introduced onto a scene of a play with a very unusual setting that you don't really know what's going on. And I'll just maybe describe it for people who are listening and not seeing the image. So there's a large centaur in the middle, and the back of the centaur is over the head of an adult male person. So it's like larger than life, larger than human size. There's a ladder leaning on the back side of the centaur's back where the horse's tail is. And there's a guy in a business suit writing some notes. And then there's like several people in white suits, but not quite medical coats, but kind of a little bit like a medical coat and a suit. And they're also taking notes. And one is on the back and one is peering in the head. And there's these various wires coming off, which it's hard to see if they're electrodes exactly or something. And they're hooking into a little tabulation machine that looks old-fashioned, like something from the 30s, like a mechanical tabulating machine. And there's these tapes that are piled on the floor. And there's a guy in a black business suit looking over the tapes, implying that there's some data coming off the centaur that he's examining. And then next to him is almost like kind of like a court jester.
Yeah, it looks like a jester.
Which is totally incongruous with the business suit type people. And he's got he's carrying a standard that has like a calligraphy L, I guess, for Levan. So the whole thing is rather surreal. And to me, like for someone who's built, like using high level computational synthetic biology tools to make new life forms, this is not consistent with what you might expect on his webpage. Unless you're looking at a very big meta scale and you're like, oh, so maybe there's other bigger things going on. In fact, at one point, he does talk about somatic psychiatry. Like the future of this is somatic psychiatry, which does overlap. So anyway, I'll just mention that I have this experience here in Philadelphia that the Kelpius monks of the Wissahickon back in the late 17th century were a millenarian group that came from Germany to Philadelphia to wait for the end of the world. And they were waiting for the woman in the wilderness. And they were like 40 monks, and they built an astronomy lab, and they did alchemy and astrology and astronomy and set up a school. And they sang all sorts of choral songs, but evidently the alchemy was for the human soul. And Kelpius was later identified associated with the Rosicrucians, whether or not he was really a Rosicrucian, but they identified with him. And there's a marker for his supposed cave, which probably isn't his actual cave, but it's maybe a spring house in the Wissahickon woods in Germantown. And you can go there, and there's this Rosicrucian monument, and I've gone there a number of times. And on the side of the monument, and I've mentioned this before, when I went several years ago, it was inscribed, and I don't know the material because it looked almost like when you draw with sidewalk chalk that's wet or on wet pavement, it's sort of creamy. It looks a little bit different. And it definitely was hand drawn, but it stayed there. It was there for several years, and it's fading now. But in Greek characters on the side of the Rosicrucian monument, it said Nephili. Now, Nephili is in the Greek mythology, and she, I'm trying to remember exactly the myth, but she's known as the mother of the centaurs. And there was a guy who was lusting after Hera, Zeus's wife, and so Zeus turned Nephili into a twin of Hera, and then Nephili was raped, and then she gave birth to the centaurs. And so there's this sort of violent digital twinning hybridization. And then lately there have been discussions in recent years that a cyborg isn't a very nice term to use, but that maybe a centaur, as far as a hybrid creature, is a more acceptable, or it feels better to use the word centaur than cyborg. And so that there's this overlap with Nephili and cyborgs and centaurs. And who in Philadelphia would go out to the Kelpius cave and write that on the side? And one day, actually, Brandy and I went out together. She was visiting. And the day that we set a little intention with flowers outside, and there was a man and his son coming up. And we were pausing because we were filming it, I guess. And I thought that they wanted to go in the cave, like, and look at it. And so we were done. We're like, oh, go ahead. And it turns out the guy was like a computational biologist that day. And he was like German or something. Wow. And he just happened to be walking by there. And so there's just many layers of strangeness for me that I wanted to point out in the centaur conversation, that actually, because Penn is a center of the synthetic, Levan is at Tufts, and Oxman was at MIT, but Penn is also a center of the synthetic biology and computational biology. So,
yeah, well,
he's also the Vannevar Bush chair at Tufts. Like, that's the name of his position.
Can you remind people, Leo, why Vannevar Bush is important?
Oh.
Not to put you on the spot, but
yeah,
the
Vannevar
MIT
Bush
Rad Lab.
Yeah, the MIT Rad Lab. He's a major part of like weapons development throughout World War II and before. He did a lot of the early computing stuff. He was also, I believe he started Raytheon, right?
Yeah, Raytheon.
I need to double check
and
that.
NSF.
Yes.
He was the first run. He ran NSF.
Oh, okay.
From the beginning. And he may have been connected.
And I think he was also. Yeah. I think he was the head of the Carnegie Institute in Washington.
And he was going back and forth with Alfred Loomis of Loomis Labs. So because at the beginning of World War II, when we weren't officially in the war, but they knew we were going to be, they couldn't put public money into developing the research labs. And so Alfred Loomis, who had his own private lab at Tuxedo Park, essentially helped set up the Rad Lab that Vannevar Bush oversaw. And so just for people who aren't familiar, even within World War II, they said that the nuclear bombs ended the war, but that radar won the war. And again, the radar has everything to do with encryption. And again, that's the whole central piece of Cryptonomicon, was signals intelligence and encryption and decryption. And once we're looking at computational biology, that has everything to do with encryption and decryption. So it's all signals. It's all about signals. It's hard to have your brain operate on all these different time scales, like thematic scales and time scales.
17th century monks and Greek mythology back there, Vannevar Bush and World War II radar.
And when I went to Cold Spring Harbor Labs, one of the buildings, it was the Vannevar Bush building. And again, Bill Ackman, the current husband of Neri Oxman, they together made it. Well, I don't know if he might have made the gift with his first wife, but they're major donors to Cold Spring Harbor Lab, and one of the buildings is named after Vannevar Bush.
All right.
Cool. Should we get into
So we have we were. I thought we'd start out with Richard Soule, right? Does that sound?
Yeah. Now this one, can we just show his bio real quick? This one is a bit long, so I don't know if we have to listen to the whole thing. But again, the person who turned me on to Oxman also shared this talk. It's actually very recent. He's affiliated with the Santa Fe Institute. And is it possible to zoom in a little bit on the bio? I don't know,
that's too small for my screen too.
Yeah, I don't have. I can read it. I don't have a way to zoom in on this.
Oh,
it
okay.
doesn't have.
It doesn't have zoom.
It says, I'm an ICREA research professor, the Catalan Institute for Research and Advanced Studies, currently working at the Universitat Pompeu Fabra, where I'm the head of Complex Systems Lab, located at lots of acronyms here, PRBB. I teach undergraduate courses on biomathematics, biological design, and C complex diseases. I completed degrees in both physics and biology at the University of Barcelona and received my PhD in physics at the Polytechnic University of Catalonia. I'm also the external professor of the Santa Fe Institute, New Mexico, USA, fellow of the European Center for Living Technology in Venice, Italy, external faculty at the Center for Education and Cancer at UCSF, at the Vienna's Complex Systems Hub. I'm also a member of the editorial.
Vienna Complex Systems Hub.
Okay.
That's really important to everything.
A member of the editorial board of Biology Direct and PLOS 1+1. I have received a European Research Council Advanced Grant, ERC 2012, and support from the Fondation Botin. I've also been a science advisor of the CCCB exhibit Plus Humans. We talked about Human Plus Humans on the future of our species, and the organizer of the Xmas lectures, the Christmas lectures, Clencia at Nadal in Barcelona, also held at the CCCB. So current research focuses...
His current research is the evolutionary origins of complex systems. So this is the complexity that we've been dealing with like the last 6 months or so, really focused in on complexity. So Leo, do you have some thoughts just about Barcelona? Because I know you've been doing work on the supercomputing stuff there. Just a few things.
So I guess, just a couple, like there's a few connections of work I've done that relates back to Barcelona. There's a company called Mitiga Solutions, which spun out of the Barcelona Supercomputing Center, which is in a cathedral. I forget the name of the cathedral, but it's kind of like it's a really shocking image. It's like a ornate cathedral with like a glassed-in supercomputer there. And what they do is third-party. They do essentially climate modeling for like insurance contracts, and often parametric insurance, but also for air traffic control systems and other like defense contractors. They also work with NATO and other things, but it's basically like climate modeling and like atmospheric modeling is their biggest thing. And they were the third-party modelers in a blockchain, basically a blockchain settled parametric insurance contract sponsored by the Danish Red Cross, based on volcano eruptions. And so they're pretty far into things. They also, like, Microsoft was a big part of the company's development. Right. They're basically integrated into the Microsoft, I believe they call it planetary computer, which is essentially like the same, ecosystem and climate modeling on a really large scale for, nature-based assets, and also just a lot of different types of financial contracts and insurance contracts and other things based on climate data. And also there's an EU organization called ERIC, the European Research Infrastructure Consortium, is creating a blockchain system for cataloging what's called ecosystem services, like around the world, and creating like credits and this sort of thing based off of that. And ecosystem services are basically this idea that you can put quantifiable value on the things that like the land does. So how rivers and wetlands make clean water, or plants air, and like all these sorts of things, and essentially creating both like a monetary framework, but really based on like quantitative data and ecosystem and climate modeling. And this is basically a big trend in, how would I put it, in essentially like the global economic system. The UN, like kind of after pretty much almost 20 years finalizing their like international economic framework for standardizing these sorts of measurements, and like having them be a part of countries' GDP and all these sorts of things. So, and that Eric group specific, there's like a bunch of different Erics, but this one's called Life Watch Eric, is based in, I believe, at least has, I think it's based in Barcelona as well, or at least has an office in Barcelona and worked there for a long time.
Okay.
Yeah.
Well, I think
And I
about
know you have some, like Twitter did a lot of kind of experiments with like app-based social, essentially like Twitter-based social governments in Barcelona, and like having people, I guess you would probably remember that better.
Yeah, there was some stuff. Jason, did you have something to say?
Oh yeah, well, just in terms of like creating these like token markets or whatever, like on top of whatever real thing that happens in the world, it's, I just think about the fact that these are all just abstractions, and then abstractions on top of abstractions, and it becomes like, think about like the stock market. In a way, it's actually really removed from the real world, but it affects the real world in like deep and meaningful ways. But it can like live, it could take on a life of its own. And that's what they're talking about. They're acting like this is just a reaction. This is just a response. And this is just a way to better manage, society and people and ecology and all these right. things. But I would just argue that that's not the case, that that's not actually what's going on, that they are, there are these artificial things that are laid on top of natural world. And so like some of the comments that Oxman coming up here makes are just kind of stunning in the way she describes it.
Well, I do want to mention too, just in terms of the story of Barcelona, because Barcelona has been set up as sort of like a rebel city, like, and like in that region of Spain, it's sort of like the anarchist and Catalan and the Mondragon cooperatives. And all of that is going to feed into the shift to decentralization and mutualism that's going to come with the complexity systems that are going to be linked to like the Vienna, complex systems engineering type of thing. So Barcelona is also important for the story that it represents. And Francesca Bria came over from Nesta, which is an impact finance space. She's the wife of Yevgeny Morozov, who at one point was like a critic of Google. But again, he would probably be pitching everybody get on blockchain, for self-sovereign identity. But they're big into the smart city. They're early out there with smart cities. And again, sort of a progressive, decentralized leaning that's going to be the story of, we'll be the anti-capitalist platform cooperative, version. But it is intrinsically linked to human capital, natural capital interlinked. And, one of the talks, I don't know that I actually included it to share because it was a little bit long, but Sepp Kamvar and Cello has given presentations in Barcelona, and he and Charles Eisenstein have talked about the role of morphic resonance, which once you sort of start to link Levan's work in bioelectricity and Oxman's work in environmental templating, this idea of a morphic field tied to a digital currency structure, it really starts to get very clear what they're up to. And you can even see in Soleil's choice image there, it's like a grid, right? It has the blocks, which are like the blockchains. And that grid to me almost looks like some of the modeling around crystallography, like crystalline structures. And Barcelona is a center for graphene research. And this is something we're not going to have a lot of time to get into, but I would just encourage people. I can include the link to the map. And, Steffers has done really groundbreaking work early on, like over 2 years ago, in this graphene nanotechnology. And as we are coordinated in our consciousness and our biology through some sort of swarm collective intelligence, it's this oscillation that I think will be coming through the nano-electrical mechanical systems and things that will be augmenting the synchronization of us at a social level, at a swarm intelligence level. So it's quite telling, I think, that that's the image that he chose for his feature image on his bio. So initially, this is Ricard Soleil. This is a recent talk. and he's talking about collective intelligence. Again, in his frame is, again, about E.O. Wilson and the ants and the termites and the wasps, and talking about comparing biological collective intelligence to artificial in this cube. And he's making a point later that there's a lot of open space in the middle of the cube to experiment bridging biological collective intelligence with computational, like with mechanical. And then
and I guess like the xenobots would be an example of that open space, right?
Filling that space. And can we go
artificial intelligence to this? Yeah.
Yeah. So, and Levan talks about this too. Like, what is the problem space that things are operating in? And he's talking about this morpho space that has like different vertices about physical, liquid, or solid. And again, fluid dynamics is a big part. How complex are they? Simple or complex? What is their cognitive ability? And that big unexplored space are organoids, or these organelles, yeah.
And like a lot of what Levan talks about is intelligence and other types of spaces. Like he's saying that traditional intelligence research is pretty much just in like the 3D, like outside behavior, but that they're a lot more interested in like physiological intelligence and morphological intelligence and that sort of things. That's sort of exactly that kind of middle space.
What is mind? What is intelligence? And I think we're conditioned to think of intelligence showing up in a brain, like a brain, like a bicameral brain, like a human brain, and that intelligence lives in the brain. And like, what is that? And what Levan is breaking it out, and Soleil too, is that intelligence isn't just in the brain, it's in the entire body through the electrical system, happening at different time scales and in different problem spaces. And outside of the body, in all of these other intelligences, and plant intelligences and bacterial intelligences, and all of these other beings. And so while we're concentrating on maybe neural networks and AGI, which are the thing that people are supposed to focus on, and not to say that it's nothing, but that's almost to the exclusion of all these other conversations, which I think are going to have more far-reaching implications.
Well, let's jump into Michael Levan. What do you think?
Yeah, so I have a clip here. Like, I don't know if you have this one on different life forms that are learning how to relate. Yeah, mind everywhere. TAME.
That's a good point that out.
That's funny.
Okay.
In this framework, we look at a continuum of agency. I don't like binary categories. I think they're completely artificial. I think these questions are empirical. They are not philosophical. We have to do the experiments and see which substrates have what capacities. We can define selves as a boundary of goals that the collective system is capable of pursuing, but it's on us as observers to recognize those goals in an optimal way, and we're not very good at it. We need a better science of doing it. Developmental bioelectricity, as the ancient precursor of what nervous systems do, is one kind of cognitive glue that binds competent subunits towards larger scale selves. And evolution, of course, interacts with this whole process, but in a bidirectional way. And so the last thing I want to point out is simply this, that when Darwin looked at the richness of variety in the biological world, he coined this phrase, endless forms most beautiful. All of the natural forms are here. They're a tiny little corner of the possible state space of every combination of evolved material, engineered material, and software. All of these things, hybrids and cyborgs and hybrids and chimeras of various kinds, many of these already exist and many more are going to exist, because all of this is possible because life is so interoperable. And the reason it's so interoperable is that evolution makes problem-solving machines. All of these systems have to, they don't take their past experiences too seriously. They don't overtrain on their priors. They have to solve problems from scratch every single time. And thus novelty is not surprising to them. They're dealing with a with a very unreliable medium. They basically, the whole architecture assumes that things are going to be broken, things are not going to work the way you expect, and you have to solve problems from scratch. And for this reason, all of these things are viable. And that means that going forward in the next couple of decades, we are going to be surrounded by creatures that are nowhere on the tree of life with us. We cannot use the old familiar strategies of asking where on the tree of life is it? Is it more like a snake or a dog or a dolphin or these things are going to be nowhere on that scale. And the old categories of is it engineered versus natural? Is it a machine versus an organism? All of these crisp categories are going to become completely useless. I mean, they were never correct, but at least in the olden days, they were a rough heuristic that you could use. And so we're going to need to develop a new form of ethics for relating to minds that are not like ours, and that's really critical.
So yeah, I want to say something too. Like all these things look like little tokens or like coins. Mm. And so like, well, thinking about like interoperability. So Leo and I have both talked about the CCIP, which is Chainlink's cross-chain interoperability protocol, which is the protocol connecting all the different smart contracts and all the different blockchains. So people are talking about, it's CBDC and one coin to rule them all sort of mindset, but it's actually going to be all these different coins that are going to be interoperable. But he talked about, to shape behavior. I don't know. I just was, again, when you hear Levan talk, it's easy, at least it was easy for me to like get wrapped up in what he's talking about, like directly, and not relating it to, the ecology to the economy, like, bridging those two things. Anyway, that was just my thought.
I mean, what you saw, Web3 and essentially smart cities and all these other things, would be in that mix of that new space that he's talking about. Like that's I think like the crux of trying to, like that's collective intelligence. That's hybrid collective intelligence, and that's just what he's doing is basically just bringing that concept in, but he's focusing on like what we would consider like the organism level. Like when you like look at this one thing, it's like, they're making chimeras or these xenobots, which these self-replicating like epithelial cells from frog embryos and stuff and whatever. But like, it's not just that scale. It's the societal level. Yeah.
Well, and he's asking for ethics, but at the same time, they're moving forward very quickly. And when Jason, when you talk about economics, what struck me early on when I started to realize like how many companies are embedded in synthetic biology, right? There's a huge economic engine behind making this acceptable. There's huge sections of the economy, the future economy, that are built on the understanding that we will embrace these new life forms as manufactured products. That's already there. Like when I went to Utah, and you would see how many companies are embedded in synthetic biology. And again, if you just ask your neighbor or someone at your church or whatever, like they would imagine that what you're talking about is somebody who's doing cancer research, or something like some sort of biomedical procedure. They're not imagining that you're talking about building hybrid animals. Like this thing would, and Levan is just very matter of fact about it, that most people are living in the story that the people who are doing this work are doing it in sort of medical therapeutic contexts, not as products, living manufacturing things that we're doing in the name of sustainability. Same with Arizona. So there are these profound economic and financial drivers that are moving, as someone who's still trying to figure out where they fit into the future of work, possibly, in my mid 50s, like how do you even, like these jobs are all embedded in this thing, even if they don't say it outright, like huge swaths of, even if you're not like the top tier PI, principal investigator, you're some lab tech, managing the petri dishes of this stuff. Like this is what this is, and we haven't actually talked about it.
Yeah. Well, there's a worldview that just listening to these people talk, that it's just, they talk amongst themselves, and I don't think it's just like normal. It's totally normalized for them to just say things that sound completely outrageous to us, and they're just all casual about it. But just
they're already living in that world,
right? But there's like some basic ethical questions, like, you know, what right do we have to even do any of this stuff? And to them, it's like that's not even, you know, that's not even on the table.
they got the
It seems
grant.
like,
The NSF gave them the money. I mean, surely it must be fine because the government's funding it.
yeah,
And
exactly.
They have an ethicist on their team.
Yeah, they've got a
the Xenobot team.
bioethicist.
There's it's a Harvard bioethicist who gave them the green light. She's like, she said she would report them if there was anything concerning.
No algorithm.
And a big part of their argument, is the, like, what they call the opportunity cost of not doing this research. So they're basically saying that if we don't do this research, people will continue to have birth defects and cancer and all these other things, and that, like, in their calculation, that this, like, if they don't do this, then like everyone dies pretty much. It's like,
Well, and there's a militaristic side of that too, which is, you know, like with AI, for example, like we have to, you know, move forward because China or Russia or whatever, like, you know, we have to beat them. You know, it's like an arms race. Exactly.
yeah, which is true. Yeah, true of this stuff too.
But there's no real discussions, like there's no genuine discussions happening to actually challenge that in any.
Well, the Xenobots like they self-replicate now. Like they were surprised. They made them come alive, and then they figured out how to like use their little Pac-Man mouths to like scooch around the tray and like gather up crumbles and make more of them, right? Like, so I mean, there's some huge questions about like, I don't know, gray goo like situations that we haven't actually come to terms with. And
we need ghosts to kill the Pac-Man. The Pac-Man, the ghost.
So,
did you play Are you too young for Pac-Man?
It took me a minute, but I know I got it.
But and I would say too, even like, you know, there were these discussions of like in the blockchain map with Institute for the Future of a plantoid, where they were imagining that a mechanical plant, quote unquote plantoid, was linked to Bitcoin, and that it would perform in public and do some sort of action that would earn money for itself. And you would pay it in crypto, and then when it got enough, it would replicate by hiring a sculptor to make another one, like an interactive art piece life form. And I would say that even like these DAOs, decentralized autonomous organizations, like they're going to imagine those as computational life forms, like superorganisms. That this is the noosphere, right? Like we become nodes and cells in a superorganism that's networked through these energetic entanglements. And I think, you know, again, maybe it's not such a far stretch because Levan puts it right out on there about like the weird centaur on his lab page. But there are these larger archetypal connections. Like on the one hand, there's these very specific mathematical computational programs of us being connected energetically through these circuits towards goal-oriented behaviors. But I do think that there's also like a spiritual energetic, like a quantum entanglement that's going to start to happen as we move into the natural assets and the tokenization, where as we move, like speed off into this noosphere, that we become entangled with all of our tokens of like the carbon trading and the, you know, the fungal leather purse that we bought, and these other things, like all of these being attached to our digital twin, digital soul token things. That like what is it even? What is life? And you know, to me, what gets complicated then is especially in light of the culture wars, like what is the role of the sacred, right? What is the role of faith or God or creative force, however you imagine God, in this world? Like to me, it's a profound hubris to imagine that people are going to create life.
Well, I think even the definition of sacred needs to be discussed, because Charles Eisenstein has kind of like taken over that word with his book Sacred Economics, and they're talking about beautiful money, and economics can be sacred and money can be sacred and these artificial systems can be sacred. And I think that that's a perversion of, for at least for me, of what like I think of as sacred, you know.
Yeah, and I'd say like you know, because I don't know how to define sacred, but you know, in terms of having like healthy relationships, I feel like that's a pretty good place to start. And the whole basis of like Levan's research, and I mean obviously computers in general, is that it's based on, you know, cybernetics, on control systems, and like that's how it works. That's what that's what he's doing. He's clear about it, like especially in the other clips, that it's just figuring out how to control the morphology of life, like very simply. And you know, it's, if when we're focused on controlling life, that doesn't seem like a chance for good relationship. And especially in like the larger scale, you know, the Web3 nature-based assets and stuff are getting like what Oxman talks about with essentially Neuralink for nature, is there's no choice. That's just integrating them into a cybernetic system, which, like, you know, like you always say, like putting them as agents on the game board, essentially. And to them, they're saying that's giving nature choice, that's giving nature autonomy and stuff.
Well, and making like plants a citizen or a players in a marketplace. You know, think about democracy and like Jeremy Pitt or whatever. What does a democracy look like when many of the agents or, you know, participants are artificial constructs that are supposedly representing a plant or some other concept or idea? You know, what does that even look like? I mean, I don't, most people, when they think of democracy, it's like, oh, you know, let's all get together and like, I have a vote, you have a vote, and like, let's figure out, you know, the best thing. But like, we're not talking about just a bunch of people here. We're talking about, you know, she says it in one of her clips. Well, I'll wait till we get to it, but she talks about the human agency going away and nature's agency, you know, coming forward. So like,
but it's also like a language, like the language of token exchange and consensus. It's like a binary language, like a yes, no, like at, you know, times trillions and trillions of yes, no's, right, into a pattern. And so like you could theoretically set up a narrative where a plant, you know, or is connected to some data set that it can vote on something, like when some sort of chemical chemosensory language translator, you know, like a phone translator of its intention through some chemical signal. But is that, you're right, would these ecological, you know, want to be in the game? Like, I don't think that, like, I think if you ask, did they really want to be in this stupid game? Like, I can tell you, I don't like this game very much.
I'm receiving a call here. 1 second. It's my fern. 1 second. They want to chime in. Yeah, it's complete madness. I mean, it's hard to like watch some of this stuff with a straight face sometimes, but
the thing is, like, he is very serious. Like, in that world, the world that he's living in his head, there is a logic to it. Like, you know, and I kind of had a little bit of a rant on my channel today because people just chime in and they're like, those people are crazy, those people are evil, those people are like this or they're like that. And I'm like, no, like in the world that they inhabit, there's a consistency of how they look at it. And in some respect, like at least Levan is open about it, and then you can debate it, right? At least it's not masking like so many of the people in, you know, Juan Benet and Eisenstein and Kamvar. They're not really being honest with what we're doing. At least Levan is just out there being like, I'm doing this. Like most people don't know what he's doing, but he's very clear about it.
Yeah, he's honest.
People, like, that's like, I have a much bigger problem with people who talk out of the other side of their mouth and obscure what they're actually doing. So, but to them, it's just normal.
Yeah.
So, okay. So again, just to hit on the fact of like using biology for computation. And this is what the map is showing here. I think a lot of this is linked to von Neumann and this idea of like the game of life and the cellular automata, like, and the social relationships of that. But then also I was really interested in that Stuart Hameroff, that is the anesthesiologist working with Roger Penrose. Like, they've been working on nanotechnology and biomolecular computing since like the late 80s, which kind of floors me. But they have a book called The Ultimate Computing and Biomolecular Consciousness in Nanotech from 1987, right? And there was another paper that he was writing about microtubules and cytoskeletal structures. So microtubules are in your brain, but then they're also parts of cellular structure, and I think they're oscillatory and vibrational. So their theory is that mind is actually not in the brain, but is out, and that like we're sort of quantum sensing systems that we're interfacing with information through vibratory systems, through these microtubules that are acting as sort of quantum computation. So again, it's somewhat of a contested theory, but ultimately it seems like there's an interest in using our embodied intelligence towards a computational purpose. And it's about problem solving I have a little dot here, like problem solving at multiple scales. And Levan talks about the nesting and sort of the spiral of the problem. So we go from like the molecular all the way out to the social. So yeah, if we want to maybe pull those first couple clips.
And that was with Roger Penrose, right? The Stuart.
Oh, sorry. Yeah, Penrose. Yeah.
Books.
Yeah.
For any kind of an intelligence claim for a system, let's say a conventional or animal or an unconventional system, we're basically taking an IQ test ourselves. And we as observers are saying we've identified or failed to identify some problem space, some set of competencies, and therefore we can make an estimate of what the intelligence of that system is to solve these problems. But that's us taking an IQ test, because we are probably missing quite a bit. I'll give you a couple of very simple examples of these kind of unconventional problem solving capacities. So here's an example with planaria. So we take these flatworms and we expose them to barium chloride. Barium blocks all potassium channels. It's a non-specific potassium channel blocker, as a result of which their heads explode. The cells are very unhappy at not being able to transfer potassium. Their heads explode.
If you
leave them in the barium,
that I'm pretty sure that barium is one of the materials, like when people sample like rainwater and these various things that like after, like barium is one of the things that shows up, I'm pretty sure. So yeah, just want to point that out. Yeah, the heads explode. Okay.
A couple weeks later, they grow a new head.
Oh wait, don't worry, guys. You'll just grow.
And the new head is barium adapted. No problem. The new head has no problem with barium. So we asked, this is really crazy. We asked, how is this possible? What's different about this new head that it can function in barium where this one cannot? And so what we did was we looked at all the genes that were expressed here and all the genes that were expressed here. And of course, it doesn't have to be in the genes. It's just it's an easy technique that's available. And we simply asked, what's the difference? And the difference is only about a dozen genes are different. So out of the space of tens of thousands of possible genes, the cells identified exactly what they need to solve this physiological stressor. Now, the key point here is that planaria never see barium in the wild. There has never been an evolutionary selection pressure to know what to do when you encounter barium. This is an example of solving a novel problem. You're hit with a physiological stressor, the cells are dying, what do you do? I sort of visualize this as being in this nuclear reactor control room, the thing's melting down, there's a million buttons. What do you do? How do you know which thing to press? Because you don't have time to just randomly turn genes on and off. You don't have time for selection the way you might in a bacterial colony. You don't have time for gradient descent. How does the system know? So this is a kind of problem solving of navigating transcriptional space, meaning the space of possible gene expression levels, to solve problems in physiological space. There are many other competencies. For example, if you study gene regulatory networks, you can find that in fact, they have six different types of learning, where turning specific nodes on and off can give them memories that change the way they act in the future, including, for example, associative conditioning. So you can do Pavlovian conditioning on gene regulatory networks. So not only our tissues and organs and cells have these competencies, but in fact, the pathways, the molecular networks inside of them also have cognitive kind of capacities, such as associative learning, habituation, sensitization, and so on. And so one thing that we think about a lot is this idea that evolution might actually be pivoting over time some of the same strategies, some of the same navigational policies for traversing these kind of spaces into novel spaces. So you keep the policy, you just change the sensors and effectors, and you can reuse the same types of intelligence that you might have for solving problems, and you can reuse them in novel spaces and of course grow them up. And so this goes all the way up through, for example, navigating linguistic space, where keeping a constant narrative through telling a story is actually a navigational task that's quite hard. Artificial intelligences today are quite limited in the how long they can maintain the train of a story. So all of these things. Share some important properties. Okay, so that's the kind of the first part of the talk. The next thing I want to do is really talk about a particular unconventional agent.
Essentially, it was about Pavlovian conditioning of cells and towards problem solving, right? And then the other piece was the paramecium with the barium saturation was under stress to find the proper answer, and then they did it efficiently. And so one of the things when I was listening to Ricard Soleil the other day, he was saying that towards the end of his life, von Neumann understood the limits of computation in the computers of the time, which had these vacuum tubes. And they were always blowing up and they were having to fix them, and it wasn't sustainable, right? Like it wasn't a reliable computing mechanism, and they were trying to look at other options. And he was actually looking at plants, Leo, because the plants dealing with like predation on the leaves and like a decentralized intelligence. So a decentralized model that wasn't so reliant on these vacuum tubes. And so he was already at that point looking at other alternatives. And so I feel like the resiliency of a decentralized collective system is what they've been looking for some time. And now they maybe through the distributed ledger system have a way of coordinating it. And to me, what I wanted to talk about with this and then the next talk is like the behaviorist aspect, like conditioning at these fractal levels, because again, he's saying the things that we're applying to biology go all the way up to linguistic structures, social structures, like how this is going to work with Web3 and Web3 in extended reality as a behaviorist structure that will essentially influence how we problem solve under stress, which it fits in with the resilient city narrative to me.
Definitely, yeah, like that. What they're finding is that they're able to, it's like resilient, but not even just resilient necessarily, but the intelligence to be able to like create a new head that is like completely adapted to that new situation. And then, so like you said, bringing that up, it's trying to figure out ways where that sort of decision making that just sort of happens, like the way it happens in planaria and life in general.
And that they might imagine that human scale systems would essentially be pulled into like a eusocial insect collectivist framework to do that work. And that to me, narratively, from, again, I think much of the surface level political ideology, economic, like which team are you on? Is the narrative that's going to get us to go into that? From someone who identified more on the left progressive side, is that they're going to push mutualism. They're going to push cooperativism. They're not going to tell you, by the way, our model for this is ants used computationally. Like they're going to make it about a cultural narrative that gets people to inhabit the story that they'll adopt this new practice and then become conditioned to it.
Well, we talked about too, like go ahead.
You can go. Okay. So like in the disaster insurance markets in space, it's you see a lot of this going on where a part of their modeling is like not just the climate and like ecological modeling, but of the local economies and the like group people and groups that are functioning in that area and how they are like affected and what sort of response would happen to a disaster, which is like pretty much precisely a larger scale example of what he's trying to get at
Right,
on
you're
like
right.
a single
Yeah, I'm
organism
seeing that,
level.
like a stressor. Like the disaster,
Yeah,
the
stressor.
parametric insurance and disaster is the stressor. Exactly.
Right. Yeah, exactly. And then, yeah, figuring out how the different responses of the people there would like be able to make decisions immediately that would like best serve that collective.
Which is why the refugee camps are computationally useful as a model. Like,
Right. Totally.
and they can make as many disasters as they want, all kinds.
Yeah, and they keep doing that. And then, yeah, you see it in all sorts of, in like all the UBI, like, yeah, like in the refugee camps and other spaces, you'll have these blockchain-based UBI programs where it's, you know, they're looking at very similar things. It's like giving people money who are, you know, have very little to live on and little shelter, and seeing the types of decisions that are made and how that, like, they learn from that, you know.
Yeah.
And it's being
Well, and if you imagine it's a
implemented
signal,
better.
it's almost like the slime mold. Like they're going towards a resource, right? In the slime mold, the resource is like oatmeal or something. Like they're
Right.
sensing, they're reaching out to fulfill their needs, and then reinforcing the systems that get the needs met. And that's what Cello is going to be.
Yeah, I was going to say it's kind of unrelated, but I was just in terms of like the collectivist idea from the left, at least the mutualism. There's all this talk about like getting rid of ego, you know, and all the meditation and you know, like the ego is the problem. You know, you need to like let go of yourself and see yourself as part of the whole. And like on one hand, I don't think you'd have to. I don't think they're mutually exclusive. I can see myself as part of this rich network of life, but also still be an individual. You know.
Yeah. But see, I don't think that the narratives come with saying there's a natural way of being in, as Leo was saying, right relationship, right? Like we are, like the goal should be, you know, being a good relative or being in balance with the world around you and others in the world, like, and bringing your gifts, you know your gifts and how to give them and all of that, that is outside of the computational cybernetic construct that Levan and Oxman are talking about.
Yeah.
Like, but unfortunately, very few people even know that this is a conversation we should be having. And meanwhile, there's a whole lot other conversations that are churning along and keeping people in a different mindset.
Yeah, and meanwhile they're going 100 miles an hour, and like it seems like every month there's like, it seems like there's a lot of progress being made on this sort of like engineering work.
Yeah, way beyond I think what people even realize.
And that we even know about too, because
on...
obviously there's.
Sorry.
No, you go. I was just saying that obviously there's a lot more going on that aren't having, you know, hour-long presentations on YouTube about.
I know. Well, today I was spending some time too on extended reality game design, like serious games and social games, and this idea of agents, because all of this stuff, even like if we're part of a super organism, we're cells, but as cells, we're also agents for being modeled, that your agency is a big part of it. Like how much choice do you have? This choice architecture aspect is really important to the computation. And I just want to say, within a lot of the conversations now, and this is what I find somewhat triggering, is when they frame it as totalitarianism or authoritarianism, which on the one hand was the case during the lockdown phase, but the lockdown phase wasn't ever meant to be permanent. It was like a collective trauma program to set up the next narrative, which will be the decentralized problem solving part, right? And so the choice architecture is coming with the agency, and the agency is connected to like the von Neumann cellular automata. So you're going to have some choice on the game board. And I've said this often, but that's an important distinction, that the first phase isn't the permanent phase. It's the introduction to what comes next. And then what comes next is the agency within a limited number of choices. So I think that's what this is about.
When the limited number of choices, I think, is really key too, because it's not like you just got this free reign. It's like they need something computable, and so they want to like narrow it down to be like, okay, this or this. But
But they also, it's like, I feel like a little bit broader than that too, because they know that what they're programming for is emergent systems, so that there's going to be decisions made that are unexpected and like coalesce with other unexpected decisions to like make unknown outcomes. And I think that's kind of a big part of it too. That's sort of like
but it has to be computable. It has to be measurable and computable. And so like for me personally, a lot of my decisions would be outside of that. Like, I don't want a smartphone. Like I'd like to have a phone where I can talk to people. I don't want that data. I don't want my data be collected, period. Like, I don't want to own my data. I don't want the data collected. But that choice, that's not on the table. That's not a choice. So as long as it's recordable, measurable, and computable, then, you know, I guess the system would probably be okay with it.
If there was no choice, there would be no computation happening. And if you try on the lens that what this is about collective distributed intelligence performing some sort of pattern recognition or problem solving procedure, if everything was absolutely fixed, there would be no point in running the simulation because the outcome would already be known.
Okay.
The kinds of systems that we're interested in exist on a spectrum, and it's a spectrum of persuadability. What that means is that there is an observer, and it might be the system itself, but it doesn't have to be an external observer. It's sort of systems are also observers of themselves and their own parts. But there's an external observer that must ask the question, what is the most efficient way to functionally interface with that system? So for example, for certain systems like mechanical clocks, you're not going to convince them of anything. You're not going to reward or punish them. The only thing you can do is modify them via hardware and or hack them in that simple sense. There are other systems that are these kind of cybernetic homeostatic systems where you might be able to take advantage of the fact that they pursue simple kinds of goals, and you might rewrite or edit some of those goals and let the system take care of the rest. And then more complex agents, you can harness rewards and punishments and let the system make all of the necessary internal changes in itself to behave differently in the future according with the experiences that it's had. So you rely on its learning interface. And then, of course, at some level, you get to systems that are able to pursue reasons, not just causes, and there you can interact with this system in a very different way. We cannot assume where things stand. You cannot sit back in a sort of philosophical armchair and say, well, this is just a machine or it's just a piece of physics or whatever, and therefore I know it has to be down here. You actually don't know that. You have to do experiments and you have to try these various stances and see what affords. It's an empirical question, which affords the most, the richest and the best interaction, hardware modification or maybe even something like this.
I think this is a really useful image. Oh, could we go back to the image, Jason?
Sure. Yep.
Because it's showing, so the second one is a goal-driven process. So that's cybernetics, right? There's a set goal and you're driving towards a goal. The training by rewards and punishments, what I thought was really interesting is he said that it's based on past learning. So in the simulation modeling, that's what your digital identity is going to be. It is the sum total of all your past decisions. And did the decisions you make get you closer to the goals that were either you chose for yourself or someone chose for you? And so there's going to be a permanent record that is central to the training by reward and punishment to inform the next phase of decision making. And that's something we've never had before. I mean, you have your own memory, but we know that typically, neuroscientists say that memory is unreliable. So you're going to have a digital representation of your memory, both you and then your memory embedded in a social context. So I feel like that's a huge change. And then some of the stuff I was looking at today was literally talking about game mechanics in extended reality. So that is going to be the Web3 programming.
I was kind of struck on this part about the idea of an axis of persuadability, and that being, I remember there are some old clips, or not old, but clips you had of someone, I guess I don't really remember well enough, but talking about ChatGPT and being able to use that to create like dossiers on people, and then using that to essentially like manipulate their thoughts and by interacting with them. And this reminded me a lot of that. It's like basically creating models of people or everything's like continuum of persuadability by certain types of stimulus, whether those are like narratives or linguistic receptions, or more basic things like food or whatever. And then like essentially, I mean, that's pretty much a digital twin, but that's just another side of it.
Or stressors, look at like how look, I just immersed with the people that are wrapped up in the whole political thing, and what it's doing psychologically to people. Like they can trigger someone, like by putting something out there. They can create a stressor.
Totally.
It's probably one of the most powerful nudge factors or whatever that's out there.
And it's really interesting because in his paper for the TAME, the technological approach to mind everywhere, he has a paragraph about basically what you just said, Jason, that he says that if you show me what stresses you out, then we can tell you your level of cognition, is basically his argument. And that it gets into a later concept, which maybe we have a clip for, the cognitive light cone, but the ability of kind of defining life or cognitive systems based on the distance of goals that they can achieve. And
I remember that. Like if you're a dog, you might be able to do something for a month, or if you're a bacteria, it's for an hour, or if you're a person, it's a time.
Yeah, it's like a bacteria. A bacteria can only find it's worried about its local sugar gradient, and then a dog just like on the next meal or whatever. And then he gives kind of a funny example of, he's like, and aliens that would have the cognitive capacity to truly have compassion for all beings like in the universe or something, being like a much larger cognitive light cone than humans. And so it's just,
again, for me, what I found really helpful about listening to Neri Oxman that built off of Levan was this idea that you could, like the goal-oriented behavior, right? So we think of cybernetics, and it's hard to visualize what that might look like. But in this case, some of the experiments, she was trying to turn silkworms into social beings, which they're normally more like on a human scale. They just operate for themselves to make their own little cocoon and protect themselves and turn into the moth or whatever. And they're not really about other silkworms. But her goal was to get them to collaborate as if they were like termites or ants, and how to do that to build a collective structure. And to me, I feel like that's what Web3 is doing, is to try to structure social interactions in a way that maybe is not natural to humans as we have understood humans to be up until this point, towards larger goal-setting, problem-solving things. And that is, when she was doing the Silkworm Pavilion, it was sort of a template. So they had a structure in which they had the silkworms operate and sort of manipulate them to, in an unnatural way, produce what they wanted the silkworms to produce. And I feel like that's what Web3 is going to be doing for us. So this idea of creating a quote unquote environmental template when you link that to cybernetics and Web3, it just makes it a lot more real. Like the UN SDGs, like there is some template that has metrics, has a leaderboard, has wearables, has us as digital, agents, and then we're performing within the setting that's available to try to build out towards the goal metrics that are set for us or whatever our team, in that space. And that's a template, that the UN SDGs are a template. And the template is also going to be not just for us, but for the entire ecosystem, which Leo overlaps with your work in the environmental service, systems, natural capital and ecosystem services, is that people will have templates, nature there'll be a template for what does a good forest, rainforest look like on a leaderboard. It's abstracted into a template and then performed. You have to perform it, but then we need the cameras in the forest, and we need the DNA barcode of life tracked, and we need the satellites to make sure everything is moving unnaturally towards the templated program.
Yeah.
Right.
Yeah.
And the template that she has here, it's all like, it's basically all run by artificial intelligence, and just the models that they set up to control the lights and like have pheromones put in different places and the temperature and everything in order to like continuously manipulate them into making that whole structure instead of just the regular normally silkworms make a 2-dimensional cocoon and not like 3D or anything.
So what they built was it was a skeleton. They built a skeleton essentially. So like all it did is it fleshed out the skeleton that they built.
Yeah.
So I mean, it wasn't like, it's not like they created anything that's even like that unique. It was literally just putting skin on the skeleton that they built.
Some parts of it were thicker than others, Jason. There was some variation.
Oh, never mind. And softer, and some were softer. Yeah, it's crazy. Okay, well.
Although the materials were different and the hero organisms were different,
the hero organisms.
I think this is hero. If you think about the imprinting of the word, because again, the semiotics and the language is super important. The hero's journey, the archetype of the hero, but think about the languaging around the early lockdown frame, right? Like that word was used a lot. That was and now, okay, so we don't just have hero medical professionals, but we have, hero silkworms, or back to your E. coli, the hero, although she doesn't seem to like E. coli very much, but yeah.
Well, I was trying to see, did we get her bio?
Oh no, I didn't get her bio yet.
Yeah, but Alison talked about that she came out of the MIT Media Lab and has her own company
essentially she's was born in Israel. Her parents were professors at Technion, whose background was in architecture and city planning. So that's important. She originally studied medicine, but she didn't complete her degree, and then she went into planning, architectural design. And so again, she bridges the biomedical and the structural. So this sort of biodynamic design stuff. And she has this family background.
Yeah. And then her husband is Bill Ackman.
Right. Yeah. And he's very important because he's with Pershing Capital, which I had done a good bit of research on him in Little Sis back in the day when I was doing impact finance. And Pershing Capital was actually one of the first funders of social finance in the US. And he was funding ed tech and mixed use real estate, planned community real estate development, and synthetic biology at Cold Spring Harbor. So this is sort of her first husband, I think, was a composer or a musician, Argentinian, and then she moved on. But there's definitely a dream team for working in that morpho space that Delay framed out. And she's quite glamorous. If you're listening and you're not watching, she has sort of brunette and poofy hair, and she's these big sort of hazel eyes. And in the Lex Friedman interview, it was like a little bit over the top, like heavy on the flirtation and the mutual admiration society kind of stuff going on.
Right.
She's definitely in the spectacle. Like she's definitely not like a geek nerd, pocket pencil protector. She's definitely more the glamour, scientist. And she's a very good, well, I don't know. She makes some people's skin crawl. I know, Leo, you had a certain reaction, but for other people, they would be like, oh my gosh, she's just so amazing,
Yeah. Well, yeah, lectures fall.
And it's like a lot of her works at like the NOMA and like bit high-end museum exhibits and like this sort of thing. It's very clearly is well connected and not like, I mean, Levan is too, but it's
a little bit more of a workhorse to me.
Yeah, Levan. Yeah, exactly.
Yeah.
Like she's very glamorous, and again, a lot of her projects, as Leo said, they're actually art installations. But in the interview, she specifically says, like, we would do these art, quote unquote, art projects, but we would also write papers about them and then get patents. So, like, her whole frame, and I know we kind of jumped right in, but is the future of manufacturing is things that are grown, not made. Right. And so it's using bioreactors to, quote unquote, grow new products. And this is very much in alignment with my research into the Berggruen Institute. And I can see that the narrative that will be framed out is that in order to address global supply chain issues and to deglobalize and relocalize fabrication, is that will happen through the bioreactor technology, through like the Ginkgo Bioworks type of things, through getting yeast to make silk and all of these sorts of things. And that will be the new, quote unquote, green and sustainable way of doing manufacturing. And it will be bio-inspired design. So,
and the art
is not made.
The art makes sense though, because so much of this technology starts in the theoretical space. And that's what the art does, is it lays out the theory, and then they can, go from there.
Definitely.
Philosophy was always the same. The approach was really an approach of computational templating. That templating allowed us to create templates for the natural environment where nature and technology could dance together to create these products. So just a few examples. With Silk Pavilion, we've had a couple of pavilions made of silk. And the second one, which was the bigger one, which ended up at the Museum of Modern Art with my friend, an incredible mentor, Paola Antonelli, that pavilion was 6 meters tall, and it was produced by silkworms. And there we had different types of templates. There were physical templates that were basically just these water-soluble meshes upon which the silkworms were spinning. And then there were environmental templates, which was a robot basically applying a variation of environmental conditions such as heat and light to guide the movement of the silkworm.
You're saying so many amazing things, and I'm trying not to interrupt you, but like one of the things you've learned by observing, by doing science on these, is that the environment defines the shape that they create or contributes or intricately plays with the shape they create. And so and you get to, that's one of the ways you can get to guide their work is by defining that environment.
So, guide their work by defining the environment.
Right. And that's going to go into the next question about the flow work that we did with sort of the whole flow series and smart environments. But I would say too, when they were talking about robotic templating with light and heat to quote unquote guide the silkworms to do what they're supposed to do, I would imagine that you could view like a blockchain universal basic income in a similar way as a social robot. Like you could program UBI and aspects in such a way as to so the silkworm had sort of basic biological needs that were being met by, moving towards or away light or heat or that sort of thing to make them act in a certain way. And I think that programmable UBI could be used in a similar way of creating the template. And then there's a degree of freedom in that, but it still has boundaries, which would be kind of like the silkworms making the pavilion.
So what's
you could definitely draw analogies to like financial DAOs, and that's pretty much what that is. It's a robotic smart contract based system for creating I mean, creating another robotic structure, maintaining it in a certain way, but for a goal, and that's what she's doing with the silkworms. Is
well, in a
kind of
DAO too. I mean, that
template.
You don't think of it as a robot, but it's interesting. So I'm doing a series of short clips that we're going to be incorporating into the talk that Jason and Leo and I are doing about Web3 and electrical templating and other stuff today. So anyway, I'm going to get started. These are a couple maps because I won't have screen share in Jason's vMix setup. And I did have a couple of topics that I wanted to talk about where I would like to manipulate my own map. So we're going to talk about an image that was taken at Los Alamos. It was a group of 3 men. It was John von Neumann, sort of father of computing and cellular automata, and then it was Stanislaw Ulam, who was in applied mathematics and statistics, including the Monte Carlo method and sort of risk and gaming, and then is it Richard Feynman, the guy who founded nanotechnology. And so it was in the context of Los Alamos. And what I wanted to try to sort of emphasize is, and this is something I've known for a bit, but the idea that the Human Genome Project is a direct extension of the Manhattan Project, that they're not separate, they're just a continuation. And I think with that context, it starts to become clearer. And then again, that Santa Fe Institute, which is the center of complexity, is an extension of Los Alamos. So this is a map that I did a while ago of all this stuff in Dallas that Lynn Davenport had sort of fed to me and I had built up over time. And there's still a whole lot of this map that I haven't looked at. And I need to get back to it because as I've looked more into this guy, Stephen Schaefer, and his understanding of video games as sort of a holographic archetypal reality where our current reality is interfaced with Jungian archetypes and myth. The centering on Pegasus Park, I had this whole plan to do a whole series linking mythology to Pegasus Park, a la, I guess, Rick Riordan and the Percy Jackson series. And I haven't gotten around to that, but I think at some point that's going to be worth my time because I didn't realize how important that frame was. But so Pegasus Park is a center for again the intersection of biotechnology and ed tech. And ed reform and a lot of impact, social impact nonprofits. And it was the former site of both, I think, Zales, which is synthetic diamonds, which is important in terms of crystallography, and also Exxon, I believe. So oil and synthetic diamonds, and then it became sort of this rundown 1970s office center, and now it's being remade as this water cooler for ed reform, synthetic biology, and nonprofit social impact finance. So, that's over here, way down in this part of the map, UT Dallas, and again, we have connections there between David Hansen and Hansen Robotics and Sophie the Robot and Texas Instruments. So this stuff, all the ed tech and social impact finance stuff is down there, but up in this corner, I was dealing with some of the nanotechnology, which was based, Zyvex Labs was an early nanoscale manufacturing in Richardson, Texas, where Lynn is based. And this guy, Ralph Merkel, and the Merkel trees, he was part of that. He was a theorist in the late 1990s, early 2000s. And of course, all of this nanotechnology was happening in conjunction with the US Department of Energy, which in my opinion, doesn't get enough airplay. But they're a major player in this. And there's also, let's see, the Zyvex, the Productive Nanosystems. This was a gathering in 2007 with Charles Lieber being on the steering committee and Eric Drexler. And later on, we'll talk a little bit about the intersection of financial markets and biophysics, but it's interesting that Eric Drexler's second wife, Rosa Wang, her first job was at the New York Federal Reserve, and then she later went into impact investing. So there we've got this early nanoscale tying biophysics to financial markets. But up here, this is the part that I wanted to mention for this clip. I was doing some research at the time, and Jennifer Lake had done a lot of this work earlier around radiation exposure and polio and the polio vaccines, and what this had to do with the Human Genome Project. And so in 1984 at Alta Ski Resort, which is outside of Salt Lake City, and Jason and I made a site visit there, it was the site where the ARPANET was first conceptualized here in 1968, I think. Yeah. So they kind of the story goes that they, wrote out the plans for the ARPANET and later the internet on a napkin at this ski resort outside of Salt Lake City. That was 68. And then in 84, there was another meeting, a very important meeting, planning out the Human Genome Project. And that was in the context of this Radiation Effects Research Foundation, which was an outgrowth earlier of the U.S. Department of Energy, let's see, what did they call it? The Atomic Bomb Casualty Commission. So after we dropped the bombs on Japan and irradiated everyone, and then we wanted to study the impacts on their genetics of the radiation damage. And so initially it was the Atomic Bomb Casualty Commission, and then in 1975 the US Department of Energy was created, and it was renamed the Radiation Effects Research Foundation. That was in 75, and their focus was, again, the genetic impact of the radiation from the nuclear bombings on the survivors and generations after of Hiroshima and Nagasaki. So that's supposedly while they were meeting at Alta in 1984 to talk about these issues. But eventually at the time they just said, you know what, guys, we're just going to, instead of just doing these bits and pieces, why don't we just plot out the whole human genome? And so that's when it began. And I would say the average person doesn't understand that Los Alamos Research Labs was a lead on that. Again, direct connection from Manhattan Project through to Human Genome. And what I wasn't aware of that Jennifer Lake brought to my attention was that, and it was a good book. Oh gosh, I'm trying to remember the name of it. It was about the radioisotopes and the history of the radioisotopes industry. But during World War II, Robert Oppenheimer had come out of the University of California, and many of the top level scientists were out of the UC system. And so the University of California took over essentially the administrative management of Los Alamos Labs. And then even after World War II, they retained that management of those systems and then added to it the Lawrence Berkeley Lab in Oakland and the Lawrence Livermore Lab, also in the Bay Area. And then those ultimately came under the jurisdiction of the Department of Energy. And you can remember that the Department of Energy is sort of a lead on this Japan Moonshot project here, where by 2050 we only exist as an avatar without access to a physical body in time and space. And the Department of Energy is central to that program, which involves sort of holographic reality and quantum computing. So, when we're looking at all of this, it's important to understand, for the most part, people aren't aware of this history. I wasn't aware of this history. And I think it's really important to sort of interface next-gen nuclear with nanotechnology, with holographic video game reality, extended reality, and with our biologies as sort of an aspect of computation that's going to be used for collective intelligence, for distributed collective intelligence in this post-Moore's Law world. Like, we're crystalline beings, and somehow our biology is going to be, if not substantially repurposed, then at least piggybacked on our crystalline nature and our network nature of social human computation, and not just humans, but us with the natural world, into a larger panpsychic Gaia superorganism for some sort of computational purpose. And I'm not really clear beyond, the initial sale clearly is going to save the planet. We need carbon reduction. That's going to be the big gnarly problem that we're supposed to solve. But it's about handing over our biology into the computational process. And that's being led by Department of Energy, and then it goes all the way back to the Manhattan Project. So anyway, just wanting to give that context. And again, the larger context for this map is that this is Pegasus Park in Dallas, which is a center of social impact around the focus on children, because the children are going to be the focus of this, human capital management, biotechnology, and impact finance and data and AI, and all sorts of things that are being framed as political ideology or woke or anti-woke, and these stories that are on the surface but not getting down to the deeper levels of what the game board actually is, and all the different interests that are running it. Right, so this is another map that I wanted to revisit. This is my big Sega map, which I don't know, I named it that, and then it's not really even about that. This is just a whole lot of sort of historic background that I've pulled together, but I wanted to focus in for this clip on this section down here. It was originally an outgrowth of some work that I was doing around Rand and this idea of noopolitique, a new statescraft, and this idea of the noosphere, which again is Teilhard de Chardin, and links to the Society for Psychical Research, that like this new evolutionary process is that we become part of a global thought form. And I think what's important to realize when we're listening to Neri Oxman talk about her plans for a molecular, like a large molecule language, is I think that this goes back, in addition to Teilhard de Chardin, we have Vladimir Vernadsky, the Ukrainian geobiophysicsist, who was also interested in the noosphere and the biosphere, and he was focused on, again, nuclear research and crystallography and the interaction of life and geology. So I think this is really important when we're imagining that they're going to come up with some sort of pods to create life from some various kinds of inputs with a molecular language. My sense is that all of that work is embedded deeply in the pioneering investigations of Vernadsky at the time, and again the crystals, nuclear research, but he was also interested in the Rig Veda and Sanskrit hymns. So we've got frequency and music in there, and so Vernadsky was referenced in the Rand document about noopolitique and statecraft, and I was making notes. I use these maps to kind of make notes of things that were talked about in that report. But Jung shows up, the collective unconscious, which is what I'm really convinced that that's where we're going, is creating a distributed cognition to access some sort of psychic archetypal reality for computational purposes. But they're talking about, Marshall McLuhan and media. They're talking about Emerson and the oversoul, because a lot of this is about our souls. David Brin, Tikkun Olam, a lot of this is connected to the Office of Naval Research. There's an emphasis on, the imperative of climate science and interest in panpsychism that we're going to talk about, and really a push towards this idea of the noosphere and shifting us into a collective commoning. And this mutualism is part of sort of the eusocial insects that we need to become. We need to reimagine humans not as people with like an ego, but as agents in a multi-agent simulation modeling. And that's gonna happen because of the whole, the climate narrative. And but it's, we're gonna save the planet by deploying a whole layer of military-based sensors that are tied into global financial markets and gamified. And then that's how we're going to get to our, spiritual Gaia convergence or what have you. So that this is the backdrop to, and I've talked about this map several times, but Trent McConaughey with Ocean Protocol, very important. I think he's based in Germany now, but born Canadian. So again, Canada being sort of on the leading edge of digital identity. And he had talked about Maslow's self-actualization, that we would actualize ourselves through token economies, exchanging tokens, and that would be in a gamified circumstance. And he specifically mentioned the game of Civilization, which I know Joseph Gonzalez has mentioned before, where it's a game where you go from primitive civilization, ultimately, if you succeed, into a space colonizing civilization. And it's part of, I think, a collective consciousness and collective computation. And it's linked to the UN SDGs, informed by the Gates Foundation. And ultimately, McConaughey is talking about, reshaping our minds into a new substrate to do space travel, right? And that would sort of be related to synthetic telepathy, in that you could reconstitute a mind into a different package and send it into outer space. So this Ocean Protocol, which is a database with a payment system for machine learning on big data systems for AI training, and also for social impact verification, that's at this core. It's connected to SingularityNet, which again is Ben Goertzel and Sophia the robot, this robot as a decentralized autonomous organization / godlike entity. And that we would be playing this game of civilization and self-actualizing in these token exchanges. And then that's where our psychic evolution, and as well as potentially our biophysical evolution, if they start to do synthetic biology programming, nanotechnology programming in vivo, that this would all be linked into like market forecasting and different kinds of currencies that would be exchanged with different species, interspecies currencies. And we're going to talk about that with Leo a little bit, about these digital wallets for animals. And that ultimately this feeds back into the James Lovelock and Lynn Margulis, like the Gaia hypothesis, right? Everything is converging into one global mind. And that this work around the global mind would be advanced through the mainstream environmental climate narrative, as well as the One Health, like linking zoonotic transmission of disease between people and animals. But really what they're going to be doing is putting in game mechanics, setting it up as participation for the common good, maybe setting it up as a public utility, and then turning it into a game where our participation in the game, I believe, is going to be linking us into a collective distributed a decentralized distributed biohybrid intelligence system for some sort of pattern recognition, problem solving, that I'm as yet unclear beyond the Save the Planet one. That's pretty obvious what the other types of actual computations might be served. But again, the emphasis here is on self-actualization, on gaming, on markets, and Gaia. Right, this is just another section of the Sega map, and I wanted to sort of talk a little bit about we're up here with Teilhard de Chardin, and he's within the context of Julian Huxley of UNESCO and World Wildlife Foundation, and Aldous Huxley, his brother. He was influenced by Lamarck, and his grandfather Thomas Henry Huxley, Darwin's bulldog. And so Teilhard Jan was sort of interfacing the Catholic faith system with this idea of planned evolution. And we have several guest posts on that on my blog. So we've got Teilhard de Chardin and the noosphere. That was informing Rand's research on noopolitik, this idea of convergence at the omega point, which to me might be this Gaia panpsychism consciousness, that they're going to hand out digital wallets to everyone and gamify it and put us all into the equation. This does overlap in the UK, I think, with the Fabian Society, and a lot of people focus on socialism, but I think ultimately this is going to be linked to mutualism, right? Program mutualism and Web3 collectivism, and that it's about drawing on human energy, the energy of our consciousness in particular, as well as our biology. So it overlaps with the Fabians and then the Theosophists in Annie Besant. So this is sort of all going on in this area, and the Human Energy Project, I think, is linked to Francis Heiligen. And I know Seb Solomon has talked about Heiligen quite a bit as well. Super important in cybernetics and evolutionary systems design. And so we have to understand that this panpsychism that they're imagining is a complex system that is undergoing emergence. And so, his focus on evolutionary complexity and being an affiliate with the Santa Fe Institute, again, we're going back to, Santa Fe Institute is closely allied with Los Alamos in New Mexico. But Heiligen looking at complexity, agent-based modeling, complex evolution towards this convergent point, right, where we all become of one mind. And he developed, he was the director of something called Principia Cybernetica, evolutionary systems theory. And here, a co-founder was Cliff Joslin with the Department of Energy. Remember how I said Department of Energy is connected with the Human Genome Project and the Manhattan Project, and the idea of biosemiotics. So when Oxman is talking about molecular language, that is the language of biology. That is the systemization of it. And I think that they're looking for a chemical component, a chemical equation for quote unquote life and soul, which I think is sort of impossible to get to. But looking at building a global brain, which is, what Oliver Reiser has been talking about for a long time. And, I can imagine that one of the presentations of this global brain would be, the Hanson Robotics ICOG brain, which is using Yosha Bach's micro-psi behavior programming system. And it's interesting that, again, Ted Goertzel's father, Ted, was a sociologist, so social systems thinking. But we've got, again, the noosphere linked to the Human Energy Project and Francis Heiligen, working on developing a global brain in conjunction with the Santa Fe Institute on complex systems modeling. And then Jocelyn was a team leader in modeling and simulation at Los Alamos, run by the Department of Energy and connected to cryogenics and magnetics and ultimately swarm intelligence and this eusocial insects. And then so that's all of Heiligen. And then over here, remember we've got the world brain, we got the noosphere up here, we're going down the other direction, and just focusing on a little bit the Society for Psychical Research, because there's a book that I've looked at, the Immortalization Commission, where they've been imagining this idea of speaking to the dead, speaking to people in other dimensions. This was in the late 19th century. High level figures in England, including Arthur Balfour, who was the Prime Minister and led the Balfour Declaration that led to the creation of the State of Israel. Lord Rayleigh, a physicist whose focus was on acoustics and fluid dynamics. His sister-in-law Eleanor, who was working with Gerald Balfour in Parliament. And then you've got illustrious cultural individuals like Arthur Conan Doyle and Lewis Carroll, as well as chemists and people interested in hypnotism. And a U.S. affiliate was William James, who was a psychologist of perception at Harvard. And it was William James that founded the American division, the American Psychical Society, with William Barrett of England, and I guess G. Stanley Hall of Clark University, who was looking at evolution. And there were several other founders, Charles Sedgwick, comparative anatomy at Harvard, Simon Newcomb, astronomer and mathematician, Edward Charles Pickering, Harvard and MIT astronomer. So you've got that. You've got Samuel Hubbard, an entomologist and zoologist. And ultimately it was, let me see, Joseph Banks was another U.S. affiliate to the Society for Psychical Research, and he became director of, and he was influenced by Sir Arthur Conan Doyle, and he was a researcher, Joseph Banks Rhine, J.B. Rhine. He was the director of the Duke Parapsychology Lab, and I talked about that in one of my last couple of posts of doing site visits to the site of the Duke Parapsychology Lab. And he was a correspondent with Conrad Hilton, who was working with Oliver Reiser on this sort of panpsychic space. And again, that's what Levan is talking about, alternate kinds of intelligences, alternate kinds of minds. And this is built on energy and crystals, I think, and human beings are definitely in the mix. And I think they're in the mix not just because they want to boss us around and use their cybernetic programs to dominate us, but actually that our biology and our spiritual technology per se, our soul and our creativity is part of the plan to use society and society in relationship to nature through token exchange as part of this some sort of programming problem. And I'm really open to know what exactly the system has in mind for us, but that's what it definitely feels like. This is part of the Decent map. Again, that's focusing on, this idea of digital democracy rebooted on the blockchain so that we can become part of the Athenian superorganism. And in this section, I want to talk a little bit about Game B. I'm not sure why it's not coming through. Game B. Okay, so it's going to move us over to Game B. I talked a lot about Jim Rutt, who came out of MIT. He was a trustee at Santa Fe Institute, and he helped develop Big Chain DB database that then became Ocean Protocol, so that he overlaps with Trent McConaughey in the other map. And this plans for the Filecoin and Protocol Lab systems, that these things are all interrelated. And again, what Jim Rutt is talking about in a complex system is that there's game mechanics. It is game B. So they're talking about a transition away from game A, which you might call late stage capitalism, into game B, which is collectivism, mutualism, but not framed as socialism or communism, but rather as eusocial insects and doing things for the common good, and to create a liquid democracy. And you think of liquid as being part of this phase shift and fluid dynamics that's being modeled on social physics. So I just wanted to talk about, the Los Alamos feeds into the Santa Fe Institute. This Game B also involves Jordan Hall and Vanessa Hall, his wife, who are both into psychotechnology and neurohacking and various sorts of biohacking, including nootropics, so getting into altered states of mind. So if they're going to use our biology and our spirit and our psyche as a computational mechanism, there are these various tools to enhance the information that they're getting, some of which are plant medicines or other kinds of chemical systems, or even just non-substance but mindfulness practices to get us into an altered state to access group mind and advance ego death. But for this, I wanted to mention, it's really important. I think what's interesting to the system about humans is that we have a certain amount of randomness and unpredictability. And that is part of the modeling for nonlinear systems. And that's something that Stan Ulam, who is in that photo, focused on. He helped develop the hydrogen bomb, but had all sorts of anxiety and eventually had a condition that led him, I don't know if he was institutionalized mentally or for physical exhaustion, but they said you have to turn your mind off and just do other things. And he was doing solitaire and card games. And so then he in developing that, a language of risk called the Monte Carlo method. So using what they call degrees of freedom or variables to make predictions about the future based on the information at hand that is incomplete information. And so when we're looking at the picture of von Neumann, Feynman, and Stan Ulam, Ulam's focus is statistics and probability and risk when you do not know all the information. And that's what he is very important at. And I think that is why the gaming is important, because the gaming is pulling in the unpredictability and the emergent potential of the players in the game, the agents, the people with the digital wallets, but not just people. If nature's going to have a digital wallet and an iPhone, to steer towards these emergent properties. So I just wanted to sort of point out, this is where Stan Ulam fits in. Over here we have the Santa Fe Institute that was founded, fairly recently, 1983. It was also home to John Henry Holland, who was the father of genetic algorithms. And again, all of this social evolution is being guided through an algorithmic process. Let's see. It was initially funded by John Reed of Citigroup. So the field they pioneered the field of econophysics, melding economic modeling with physics, but then also it's overlapping with the biophysics as well. And what's interesting to me is that their first offices were in the Cristo Rey Convent in Santa Fe. So it does sort of overlap in terms of the archetypal narrative with the things we've been talking about in terms of the dome of domination and Western society over indigenous culture of the Southwest, which had its own like amazing cosmology of and worldview. So anyway, so that's the piece that I wanted to talk about with Game B, gaming mechanics, and the intersection of consciousness, nootropics, game design, prediction signaling, and pattern recognition. I've talked a little bit before about the degrees of freedom, right? Like you can't have computation if everything is fixed, but there's not unlimited freedom. There's a limited choice. And in one of these images that we're going to show later with von Neumann and Feynman and Stan Ulam, Ulam's focus was on statistics and risk, which is really in line with Leo, with your work. And then making predictions in nonlinear dynamic systems. So making predictions in systems where you don't have all the information. And that's really what's sort of behind the parametric insurance and these open-ended questions, that you have some of the information, you don't have all of the information. So there's an emergence. And the Monte Carlo method is a way to get towards that. And that was, Ulam was, I think he was overworked and they said, you have to turn your brain off and we're going to put you in a hospital. And he played cards. And then he came up with this new method of how to do the statistical probability. Now, I will also say that Ulam, I think in the mid 60s, brought a bunch of mathematical scientists together at Penn to revisit Darwinian evolution and said, it doesn't actually add up. Like the way we understand it, it doesn't actually work mathematically. It was highly controversial, but I think at this point is probably more in line with like some of the Lamarckian, like, and this idea of that there might be large jumps, like points at which it's not one slow, steady progression, but at certain points, there are bigger jumps in evolution that happen all at once mathematically. And it was controversial at the time, but I think probably more likely now they would imagine, especially given what Levan and these guys are cooking up, that there are places where big jumps happen in evolution.
Did I send you that clip of Barbara Marx Hubbard from the Transpartisan conference in Denver that I filmed? There's a clip that I have of her that I filmed of her when she was talking about Ilya Prigogine, who was an evolutionary biologist, and she was talking about, in biology, there's all these things that are happening independently that look like they're not related. And then she said that there's this, and then all of a sudden there's just like this jump, like all of a sudden this evolutionary jump, exactly what you just said. So she was promoting that idea actually at the Transpartisan event that I filmed, over 10 years ago.
So it was earlier, at least Ulam was doing it earlier.
Oh yeah, of course. She was.
Yeah, but it's still out there. So, anyway, we can just insert the little clip that I did to talk a little bit more about Stan Ulam, but he
That's
like it's embedded a bit in the Los Alamos project.
Okay.
Leo, did you want to say some stuff?
I guess a little bit like what Levan was saying about the planaria and barium is an example of, I would say, like one of those, how there can be those big jumps in evolution. Like I haven't studied Lamarck or really know that much about it, but that jumped out to me as like a pretty strong example of that. And he seems to not really beat by natural selection as like a
I hadn't thought
main
about it that
driving
way,
force in evolution.
Let's try to kill these things and see how they react. If they can figure out how to survive.
It's like just torture salamanders and frogs indefinitely.
What was that reality TV show where they would drop people off on an island and see if they could survive?
Survivor.
Survivor, yeah. Like, planarius survivor. But they're immortal.
Right.
So do you want me to say something about this before we start it? So this is one of, I don't know if it's actually an art project or just a weird community design thing. Evidently it was somewhere in suburban Boston, and they created a perfect apiary for bees for the winter, to overwinter these bees. And so it was supposedly quote unquote perpetual spring in there, and they made fake pollen, and they kept the temperature at this quote unquote perfect temperature, but there's like no actual flowers or anything. It's all contrived. And to me, it looks sort of like Kubrick 2000 Space Odyssey. Oh, we just send bees into outer space too. And so to me, that's, again, an embodiment of a planned community, right? This smart planned community that would be an example of, if you scaled it up to humans, it would be Flow. It would be Adam Newman and Mark Andreessen, which I'm sure know all about what Levan and Oxman are up to. Like, clearly they would, I'm sure they're invested in all of this stuff. So to me, this project with the bees is just emblematic of the smart city.
So we built what we called a synthetic apiary. And the synthetic apiary was designed as an environment that was a perpetual spring environment for the bees of Massachusetts. They go in hibernation, of course, during the winter season, and then we lose 80% of them or more during that period. We were thinking, okay, what if we created this environment where before you template, right, before you can design with, you have to design for, right? You have to create this space of mutualism, space of sort of shared connection between you and the organism. And with bees, it started as the synthetic apiary. And we have proven that that curated environment where we designed the space with high levels of control of temperature, humidity, and light, and we've proven that they were reproductive and alive. And we realized, wow, this environment that we created can help augment bees in the winter season in any city around the world where bees survive and thrive in the summer and spring seasons. And could this be a kind of a new urban typology, an architectural typology of symbiosis, of mutualism between organisms and humans? Where these, by the way, the synthetic apiary was in a co-op in, nearby Somerville. Mm-hmm. We had robots. Our team, schlepped there every day with our tools and machines, and we made it happen. And the neighbors were very happy, and they got to get a ton of honey at the end of the winter. And those bees, of course, were released into the wild at the end of the winter, alive and kicking. So then, in order to actually experiment with the robotic queen and idea or concept, we had to prove, obviously, that we can create this space for bees. And then after that, we had this amazing opportunity to send the bees to space on Blue Shepard mission that is part of Blue Origin. And we, of course, said, yes, we'll take a slot. We said, okay, can we outdo NASA? So NASA in 1982 had an experiment where they sent bees to outer space. The bees returned. They were not reproductive. And some of them died. And we thought, well, is there a way in which we can create a life support system, almost like a small mini biolab of a queen and her retinue, that would be sent in this Blue Origin New Shepard mission in this one cell. And so that if the synthetic apiary was an architectural project, in this case, this second synthetic apiary was a product. It was, right, so from an architectural controlled environment to a product scale controlled environment. And this biolab, this life support system for bees, was designed to provide the bees with all the conditions that they needed. And we looked at that time at the Nasonov pheromone that the queen uses to guide the other bees. And we looked at pheromones that are associated with a bee, and thinking of those pheromones being released inside the capsule that goes to outer space. They returned back to the Media Lab roof, and those bees were alive and kicking and reproductive, and they continued to create comb, and it ended with a beautiful Nature paper that the team and I published together. We gave them gold nanoparticles and silver nanoparticles because we were interested if bees recycle wax. It was known forever that bees do not recycle the wax, and by feeding them these gold nanoparticles, we were able to prove that the bees actually do recycle the wax. The reason I'm bringing this forward is because we don't view ourselves as designers of consumable products and architectural environments only. But we love that moment where these technologies, and by the way, every one of these projects that we created involved the creation of a new technology, whether it be a glass printer or the spinning robot or the life support system for the bee colony. They all involved a technology that was associated with the project. And I never, ever, ever, ever want to let that part go because I love technology so much.
I will never, ever, 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 from my cold, dead hands, never. I think those bees were kicking and screaming the whole time anyway. She's like the Adam Newman for bees. Like instead of we work, it's bee work. Yeah, I totally see the flow thing going on there, big time.
Yeah, that was a lot more clear to me watching it the second time. It's like, oh, that's the Smart Cities flow, Adam von Neumann. That's like
even think about
a lot more obvious.
We have to work like with them first before we can build for them. And to me, that feels a lot like lockdown culture, like a structured environment where we were confined, we were enclosed, there were the circles, right? Everybody go sit in the circles out in the park, stand on the dots, do the thing. Like it wasn't totally contained like in a room, but there were ways that we were supposed to totally restructure our lives, again, in the name of for the good, common good, right? So it was a eusocial narrative framing. Like you had to do this for the common good, which was for the colony, really. And that we were contained often physically, or if not within like geofenced aspects of the bees, which to me, like it seems pretty clear, like that was a learning experiment. Like all of that, and then putting life into the virtual sphere, that was like, oh, well, we need to learn about you until we can build with you. So it was like we were in the petri dish of that for those several years, and then all of the digital dust and the trauma that went with that got programmed into the simulation. And the pheromones is really important, and we're not going to have time to go into that in great detail, but that's something, again, that Steffers was sort of doing pioneer work on about stigmergy and swarm intelligence. And even in Philadelphia, this Monell Chemical Senses Center, which happens to be right across from the ISI Garfield Institute, the guy who was doing the father of bibliometry, and his dissertation at Penn was essentially a chemical molecular language, like the linguistics of chemistry. Which is essentially what she's talking about later. She's talking about developing a language model of molecules, which seems to be a direct extension of Garfield's work. So that's directly across from the Monell Chemical Senses Center. And then I do have in the map, someone had recommended, my friend Sean, that I watch the movie The Congress, which is sort of like mostly an animated film where people are living in this weird extended reality, and the access point into the animation from real world was through sniffing an ampule that is a specific chemical compound that transports you into a virtual world. And so there is this really weird thing about chemical signaling through olfaction, whether it's an actual scent or something that's inhaled as a drug, I've talked about before, the Yu Yuan of the IEEE. He was saying like they've got it down with the haptic senses and the eyes and the hearing, and the next key things for extended reality are the chemical sensing, is taste and smell, which just so happened to be the things that people had a lot of issues with during all the lockdown stuff, was the chemical sensing. So there's a lot of really weird and strange things embedded in this. I don't know what if you call it an art project or a scientific experiment there, even including feeding them gold nanoparticles. That feels very ritualized, like an alchemical aspect to that.
Yeah, that part really didn't make that much sense to me. I was like, why? For figuring out whether bees recycle wax, there'd probably be a lot simpler ways of doing that. There's definitely a lot more going on with that specifically.
Yeah, I don't know. I mean, it made sense to me that like they'd be able to track whether this was the same material as before, but maybe there's something else going on there.
Yeah, I mean, I'm sure that they could do that, but there's
They couldn't just
This-
look at the bees
you get
and put a
this
little
simple-
simple in there, see if they were eating it or I don't know. Seems like they.
Yeah.
Yeah. But don't worry, guys. They did it in a co-op. Again, co-op. So it was all good. The neighbors were happy. But I don't know why they had to bring their robots to the bees. Did you catch that? She's like, yeah, and we went there every day with our robots. I'm like, what?
Yeah,
What
she
kind
didn't
of
mention
robots
that.
are we talking about,
yeah,
Neri?
she didn't tell.
Which robot?
Yeah, I feel like it was
What's
similar
scale of
to the
robot?
They're therapy
silkworms.
robots because the bees were having a hard time. Oh man.
Well, I think that's mostly what I wanted to talk about. Like, yeah.
Well, we got
Yeah, and there's the obvious like larger scale repercussions of like you can. I mean, for me, it was like the at first it was like the synthetic or not. It wasn't synthetic pollen, but it says pollen substitute.
Yeah, synthetic.
on
Yeah,
that little image
substitute or
there.
something. There's no flowers in
Yeah,
there.
it's like yeah, exactly. It's like that. There's something to that, you know.
it's
It's like,
something
that's-
mental about it.
Well, it's
Yeah, you
interesting because,
can't-
like, I know I go back to these books sometimes, but A Wrinkle in Time, you know, when they go to Camazotz and they have to eat this food, and I'm trying to remember which of but it was essentially just paste, like it was the human equivalent of pollen dust or whatever, like sawdust, and like for one of I can't remember if it was Meg or Charles Wallace, but one of them it just tasted like sawdust, but the other one they could make it taste like anything. Like a turkey dinner. And they're like, well, why are you eating it? And they're like, well, it tastes like sawdust. I'm like, well, for us, it tastes like a turkey dinner. And so there's that. And then I would say also this quote unquote ideal environment, that's straight out of Walden 2. That's straight Skinner. Like in Walden 2, they created this eusocial environment for humans where like families didn't take care of their children. The children were all like in a nursery away from the families, which is like a beehive program, and that everyone was optimized for their gifts and all of that sort of thing. So yeah, it's very
yeah,
Skinner.
the Skinner connection. Mhm.
Yeah, if you connect it to Levan and what he's saying about cellular conditioning, there's a through line.
I'll have to find that clip from the
Yeah.
Dorito effect because they talk about that with taste. You know, using chemicals to trick your brain into to thinking that it's a certain taste that it's not. That's actually that's a real thing that they actually have in artificial flavorings.
Yeah. Well, I would say too, I just want to like emphasize that we talked about Bill Ackman. Like he was Pershing Capital, and they have a foundation. He was funding social finance, Ronald Cohen, you know, and again, it's been a while since I've like framed everything within social finance, but in 2011, that's when it first came. Like it was in the UK in like 2008, but it came, Bloomberg brought it here in 2011. So they were in on the ground floor with social finance. And if you start to think about, again, the words social, like if you start to consider it as eusocial, right? That it's not just society or measuring you within a society or the goodness of society, but the social is actually like social computing or eusociality or that. Like I think these words are carefully chosen. So to me, it's very significant that the two of them being on the same team. So I
here's
think
a
the
short
next
one.
one, I was going to talk about the iPhone, nature and the iPhone.
Okay.
But could we just bring up the playlist of the work that we did in the atomic ecologies? Because I think, you know, it's kind of amazing. The like we're really like I love revisiting some of this stuff in the context of our past work about like the whole flow series and then this atomic ecology. Because I mean, can you remind me, Leo? Can you say a few things about like the radioisotope in Hutchinson and how it worked with the tracking?
Yeah. So, yeah, no, I was like, oh yeah.
I don't want to put you on the spot. I know, but I don't want to.
No, I do. I can. I remember. If,
This is really your baby. Like this is your work.
Yeah. So the Oak Ridge National Laboratories, which was constructed like very quickly during World War II as a scale up for essentially doing the first test reactors for refining uranium for the bomb. Like before the bigger ones were out in the name's leaving me, but in Seattle, the Hartford or
Hannaford.
but
Hannaford, yeah.
Hannaford, yeah, that's like where they did it big, but they had to like first do test reactions, like smaller scale ones, and that was primarily Oak Ridge, and it was like pretty much, or was set up by Monsanto, and Charles Allen Thomas was like the main figure there, and there's like letters from Oppenheimer and General Groves about like how essentially he figured out, or like they figured out the big like chemistry issues that no one else was able to, about refining uranium into polonium. I probably have that wrong, but essentially that sort of like base chemistry that was essential for the bomb and everything else. And sort of as a byproduct of that, and during that, there was a health, it was called the Health Physics Department, that was created essentially to like monitor the effects of all this radiation on workers and people and study it. And through that, they started figuring out that they could use like the nuclear waste and the because the atoms are traceable throughout the environment and throughout the bodies. So the waste going through the like, because they just put it in the ground, you know, there wasn't not even like
what kind of crazy
line,
plants
like,
can we grow if we irradiate the ground?
Definitely. And so that's how so they started kind of doing ecological studies, which it was done through the Health Physics Department first, but eventually kind of became its own thing. And then so through the soil and through the waters, they would like inject trees, they would grow crops and see like just kind of what happened, you know, what radioactive materials would be absorbed into the plants and whatnot, and how it would flow through them and all that sort of thing. And it ended up being like, after the war and trying to sell atomic energy and all these things to people, a big part of that was radionuclides. So using these tagged isotopes to use in medicine and science in order to like essentially kind of the start of precision medicine and seeing how things like really travel through the body and all that. It was how they figured out like the chemical process of photosynthesis and all this stuff, because you're finally able to have like individual molecules traced throughout the entire system, because before you just couldn't see it, you couldn't actually observe what like chemical transformations were happening. And subsequently Oak Ridge became basically the birthplace of ecology as a science, and having mathematical quantitative representations of the flow of energy through ecosystems. And that was enabled because of the radioisotopes. So they were able to see like the things we hear, like what kids are taught in school about the carbon cycle or nitrogen cycle or water cycle. That's all pretty much based it's based from this work at Oak Ridge, and spawned like ecological science in general. And then through that, and later on, you know, you get into this whole world of this modern ecology, and it's all very quantitative based, but
early track and trace, right?
Yeah, early track and trace, but yeah, that's kind of
in an energy language, like a language of energy exchange.
And then I think we talk a lot about in that the International Biological Program, which was in the 70s, the early 70s, and was kind of a scale up of applying that kind of thinking and that kind of mathematical energy mapping of the environment into like all different biomes and all different types of ecologies. And it was the opposite of predecessor, the successor to what's called the International Geophysical Year, which is where that's like where Sputnik was launched. It was basically like an international effort for geophysical science, and was kind of had the establishment of, or working towards kind of like, I mean, in a sense, like is somewhat credited as like building the international scientific community in like a much broader way, like this kind of like global alignment of like quantitative research. And yeah, there's a lot of interesting things about like a lot of research in Antarctica, and there's kind of different questions, and that's something I've been meaning to look more into. But yeah, and then yeah, well, I guess we'll stop there. But
Well, I just want to mention too the Odom brothers, who were sort of central to the ecological, like setting up the ecological framework for education in the U.S. Howard and Eugene, right? I don't know if you remember, but their dad was a sociology professor at University of North Carolina, Chapel Hill. So it's really interesting to start to think about like the social physics aspect of it. Like he was sort of a progressive sociologist, but like this gaming stuff is moving into computational sociology, where we have track and trace with, instead of, dosing you with radioisotopes, you've just got your own personal tracking device, iPhone or smartphone or wearable smartwatch, that sort of thing. Eventually your own, nano machines.
And your AI dungeon master.
Your AI dungeon master. And the other thing is, like, a lot of that early medical stuff during World War II, like monitoring, was connected through Rochester. And Rochester is the center of optics and photonics, and historically was a center for lenses. So Bausch and Lomb, I think, lenses for military use, and then lenses for cameras. So Kodak, Eastman Kodak, which had connections to Oak Ridge, I think their land was used for that process. They had timberland there for the cellulose, for the celluloid film. And then also Xerox. And then Xerox later became a division of Xerox PARC in Silicon Valley, which was early, like very advanced pioneering in a lot of these internet technologies. So as we think about digital twinning and next gen nuclear and biophysics, like there are these interesting synergies between Oak Ridge, Los Alamos, MetLab in Chicago, Center of Human Capital and derivatives trading, and Rochester. In a lot of those experiments that were done in Rochester, there was biomedical monitoring, but they were also dosing people with radiation without informed consent. There was a lot of really unethical behavior that was happening. And that hospital in Rochester was funded by the Rockefellers. It was one of the early Flexner hospitals that later became also a big psychiatric hospital. So there's just a lot going on in all of that stuff. But I think ultimately, like for me, like connecting the track and trace to big data simulation modeling, which you work so much with, Leo, in Natural Capital, to the phone and her saying that they want to give nature an iPhone so that they can tap into nature. Mother Nature can tap into our quantum computing system. Is just, it has all of this history behind it that needs to be considered.
And that health is like a big connecting factor with it too, because the forced experimentation. And I remember you sharing a big, long, it was like a PhD thesis, I think, on it was in St. Louis on the radio. I forget the exact chemicals they used, but it was straight up an Army and industry test in poor, predominantly Black neighborhoods of poisoning them with radioactive materials.
Yeah, with radioactive material. Right. And now we're going to call it next gen nuclear and radiation hormesis, and to tell everybody that it's good for them. Like that's what Mark Andreessen and the Coke Industries is going to set up.
And I didn't make the Monsanto connection because they're based in St. Louis, and then they're the ones that were doing that in Oak Ridge.
Well, I was going to ask, like, where does DuPont fit in? Did DuPont come in later? Did they manage?
DuPont?
Did Monsanto built it?
I think Monsanto's older than DuPont.
DuPont actually built it, I believe. Like they did the actual building, but I think Charles Allen Thomas was pretty much overseeing it in his group, and they worked very closely with the University of Chicago the University of Chicago metallurgic group, which did like the very first chemical synthesis for that. But then then DuPont took it over. There's kind of a weird timeline. Like I think DuPont took it over very quickly, like a year or two after. Like they took over management and everything, and then it went through several contractors. I think Battelle had it for a really long time. But
yeah. Well, I would just point out
that also the first computer
that are living through chemistry, right? And how that fits into everything. And DuPont being really interested in your microbiome now. And in the talk, Ricard Soleil was saying like, oh, well, we have to understand that we're not just, ourselves, we're our microbiome. He's very interested in digestion, and particularly in digestion as it relates to your brain. So the whole vagus nerve, gut microbiome, brain function, controlling all of that is super important. Like they're really interested in that. And again, if you take it all the way back, watch.
And we didn't really get to talk about it too, but at the Weiss Institute, the research that Levan he's like plays a smaller role in what they're doing there at Harvard, but it's all primarily organ on a chip research, which is basically like creating micro organs in kind of like the things that Oxman's doing with the very controlled environments, like the bee life support system is essentially what they're doing with organs, primarily to study the microbiome in the organs. And that's something I didn't really realize before with the whole organ on a chip thing. It's that it sounds like one of the main reasons they do it is to have very controlled situations for studying how the microbiome in like digestive tracts and other parts of I guess primarily digestive tract functions, because you can't really study it in vivo, like in full organisms for whatever reason. It's hard to get the sensors and the data and do experiments and that sort of thing. And Levan, so and it's DARPA too, which was another just of course.
Wow. Well, I mean, and I know like there are a lot of people who talk about like illness and connection to like biofilm and mold and things in the body, like other microorganisms. And once you think about what Levan is talking about in terms of other kinds of intelligences, right, and co-inhabiting like your biology, it's interesting to think about.
Yeah.
Okay.
But we're constantly seeking to ask how can we build, design, and deploy products in 3 scales: the molecular scale, which I briefly hinted to, and there in the molecular scale, we're really looking to understand whether there's a universal language to nature and what that language is, and then build a tool that I think and dream of it as the iPhone for nature. If nature had an iPhone, what would that iPhone look like?
Does that mean creating an interface between nature and the computational tools we have?
Exactly. It goes back to that 11.5 quintillion times the bandwidth that humans have now arrived at, and giving that to nature and seeing what happens there. Can animals actually use this interface to know that they need to run away from fire? Can plants use this interface to increase the rate of photosynthesis in the presence of a smoke cloud? Can they do this, quote unquote, automatically without a kind of a top-down, brute force, policy-based method that's authored and deployed by humans? And so this work really relates to that interface with the natural world.
I just don't know how plants and animals have made it this far without this, without an iPhone. Yeah.
Leo, do you want to respond? I know this like really grated you.
Yeah, I mean, it's just like, some of this stuff almost seems like intentionally triggering, it's like trying to get your response, because of course it's insane that you want to attach I mean, essentially control plants with computers in order to achieve certain objectives, which oddly enough she like tries to say in the middle of it that that's not exact. That's
Yeah,
what
she
they
says
don't
we're
want.
not
They don't want
controlling
to do
them.
that. They
We're
want the
giving them a
plants.
voice. We're giving them a voice.
Yeah, we're giving them
We're putting them in the template.
by giving them the opportunity to access the data to tell them to change the way they do photosynthesis in the case of a smoke cloud or something.
And earning
It's just
potential too.
crazy, but yeah, that because like with the nature-based assets and the ecosystem services, it's sort of, sometimes I think of this stuff as like, you know, there's so many directions that there's verging towards that if you take this in isolation, it seems really kind of silly and out there and not, you know, not even like economic, or there's no like point to it necessarily, and seems like.
But you know that Ledgard
kind of
has those wallets.
Yeah,
I mean,
exactly,
the thing
and
is,
that
you talked about that. So when they're like, "How will the animals know to run away from the fire if we don't give them an iPhone to tell them?" Well, that's a digital wallet. That's Ledgard's digital wallet.
Yeah, exactly, and that the data generated from them being connected to the cloud is the same data that's will be driving the internationally set standards for ecosystem services and nature-based assets and carbon credits and all these things that already exist and are being built and are built. And it seems a lot more like, once you realize how big of a like economic engine or backbone there is to implementing this sort of stuff from like the other side, where like if you look at ecosystem services, it seems like into the UN statistical details, it's not like glam, like, you know, it doesn't get a rise out of you the same way that this sort of stuff does, but it's pretty much the like cognitive infrastructure you need in order to create like economic flows out of putting animals and plants into like a computer interface.
Yeah, with smart contracts. It's like, can a plant enter into a smart contract, really? But I mean, it's not fringe.
But
go ahead.
But they can't. Like, what's crazy? It's like they can. There's. She talks about it in this interview. I'm not, probably not in one of these clips, but that just they've done, like, you can connect just neurons like in a petri dish to like a Pong game, and they can play Pong. You know, it's like, as long as there's just, you just force the connection to the organism, there's gonna be like interaction electrically, because it's just like what they are. Like, same with like the Neuralink chimps and playing Pong, like what you know, that's what that kind of famous image of the chimpanzee wired up and is playing Pong. It's like, it's not that it's like less, I mean, it's really out there, but it's less mystical than it seems, because all they really need is to have any sort of electrical interface, and then you can kind of reprogram it as you go and refine it in order for things to happen. And of course, like, they're not gonna do exactly they say that they'll do, but they'll just, you know, continually refine the types of responses that they get from the plant and how the computer interprets them and then sends it back and learns how to do like the Levan stimulating the ion channels and the various like neurotransmitters that plants have and stuff in order to like send their feedback back. And that's what's crazy. I mean, it's really not that it's pretty much all built technology, definitely at like a lab, like small scale.
Mm-hmm. Well, I imagine there's so much room for any kind of manipulation. I mean, that's what it's all about. It's about manipulation. I mean, they openly say that, but then then they talk out of their mouth, the other side of their mouth, and talk about the natural world and, you know, given agency to it. It's kind of crazy.
yeah, like she has a line in one of them that's like, yeah, you know, we came up with the equation that tells us what nature wants, and what nature wants is to reduce entropy and maximize information.
Yeah.
It's just
I
like
think that's what Bill
it's the
Ackman,
stupidest thing
First
ever.
Capital wants.
All right. Well, that's a Bill Friston thing too, the entropy.
Well, I just want to sort of point out, I'm not sure. I think I have a couple of, or maybe this is the next one up after this, but there's just a couple clips and we don't have to listen to them. You can just sort of splice them in. But like there is this aspect of the noosphere and Gaia, right? And I think I'm trying to remember that guy, Jake Kleizek or whatever. He's like, the New Age and Barbara Marx Hubbard are going to take over the universe with their, like I think the Gaia stuff was part of that. But what they're not layering in is that, like, I do think that there is this push towards, the networked intelligence, right? This directed evolutionary imperative of Desjardins and Vernadsky that we're going to be part of some sort of networked distributed intelligence, and then that maybe that network is happening through everybody having their equivalent of an iPhone or eventually nanomachine that is energetically connected onto these distributed ledger systems. So I feel like this is a representation of the noosphere that is intrinsically linked to global financial markets and digital surveillance, ubiquitous digital surveillance and global finance. So it's all of the things. It's like the economic imperative. It is this evolutionary imperative, and yes, it does have a framing. Like I need to get back to it, but I've been reading this book about greening the paranormal, which is essentially about it's looking at sort of this Gaia principle through like shared consciousness of all, like an animist world, but in the name of the climate crisis, right? And so this is all feeding in. And then I was revisiting the piece of the map with Trent McConaughey of Ocean Protocol, talking about self-actualization, like how we self-actualize through participating in token exchanges for ESG investing in game mechanics, a la Civilization. Oh, and a side benefit is that we'll have our brain in a blockchain mine file that we can send into outer space if we need to, like if the AI shows up. But this idea of game mechanics and self-actualization, and I think it's Lovelock and Margulis, they were the two that promoted the Gaia hypothesis, that is situated within the noosphere. That it was my context for that was the whole Rand no politique work. But within making that map, I had Vernadsky, and Vernadsky, is biogeochemistry. Well, you listen to Oxman, and that's what she's talking about, right? A universal language of life reduced to biochemical signaling. Like that's what she and Levan are building, is Vernadsky's, like Vernadsky. And then I found out later, like Leibniz was developing this characteristica universalis, the universal language of life. But like what do we understand life as? Anyway, it's just interesting to keep going back to these things and seeing it with like a little bit more information, a little bit more clarity on how they imagine they're going to do it. I'm not going to say they actually can do it.
It's interesting with Lynn Margulis, and so if I remember correctly, what she's famous for is the endosymbiotic theory, like of how basically the theory of how multicellularity arose, and that kind of proving that like prokaryotic bacteria consuming each other can create like the bacteria that they consume like can still operate within them, and essentially became like the organelles of eukaryotic cells. So like the mitochondria like that some bacteria engulfed another bacteria that's ended up becoming mitochondria, like that sort of thing. And I'm pretty sure that's like that's what she's really famous for, and which is really interesting too, because thinking about Levan, and it's essentially the same sort of stuff of collective intelligence and how
mutualism.
Like how
Right.
right there, and then.
Well, again, this is not
And
just in the biological space, because like I said, her husband is investing in planned communities, and like the relationship between tokenomics and planned communities is huge.
Yeah. Don't worry, you're going to get your equity and your good behavior, Jason. Yeah. I don't think
I guess
Leo
one
was
last
done.
thing too. It's like with what she's talking about is, if you want, you can just spend time with plants and these things and like stare at them in silence, and you'll experience a relationship. And like this isn't that, like the
No, it's
wiring
not
them
that.
up. It's like, if you want to actually do what they're like, you can if you want to like share your consciousness with plants or anything else, you can do that if you want, if you just like spend the time and focus and do it. But like this inferring agency and all this flowery stuff without like, they're not even, there's no actual respect and no actual relationship. It's just it's just control, really. But
Yeah.
like or not even
Domination.
control, but like domination.
I mean, it's control in not like an overt. It's managed. It's management, I guess, maybe would be a better word. I don't know.
Yeah, it's like
It's
exerting
hard.
their will. Yeah, it's hard and it's complicated because I mean that's part of,
Because like I think we would all
like, with the
consider ourselves people who care about being in right relationship with the environment, right?
Yeah.
But there aren't very many voices out there who are contesting the cybernetic control grid version of sustainability to say that there should be other models of being in right relationship that would begin to address the profound out of balance nature that we're in, right? That it's not like there's no problems. There are problems, but the solutions are not going to be those. And it's so hard because even, I wrote about going to this job interview at Penn, mostly because I just wanted to find out if these environmental humanities people were actually like going to sell carbon credits. Is that their version of caring for the environment? And the reality was like, yeah, of course, that's how we're going to do it, and it kind of breaks my heart because I mean, what a lot of what these people are talking about is true. Like, I mean, they're talking about people who have connections to permaculture, having these experiences of like other, extraordinary experience in nature that is something that's, documented, but none of, and this book came out in 2019. This guy isn't interrogating impact finance. He's not asking what Ackman is planning or, I can imagine Andreessen and Newman coming up with some sort of vertical, GMO microgreens wall in their smart communities to have the children tend them for multiple layered vertical impact markets, right? Like we'll train the children in synbio hydroponics with the, optical genetic lighting and the whatever. Like they're going to make a bastardization of everything. And yet we need more voices. And to me, like situating it in an Indigenous right relationship frame is vital. But at the same time, Indigenous communities are the ones being used, like, they're being fronted to Indigenous wash a lot of these like rights of nature structures that are really just an excuse to like surveil Amazonian villages for NF tree sales.
Well, it's interesting you said rights of nature because they're even using that language, like in order to advance this. Like there's these rights of nature. Yeah, as opposed to like, like you don't need to like codify it. You don't need to pass a law. You don't just leave it alone. Like it's not. You know what I mean? Like it's not that complicated.
Right.
Yeah.
Did we have the picture? Did we already talk about the picture?
No, I brought it up for a second there, the von Neumann.
Oh, okay. So when I saw this, so this is, I think left to right, it's von Neumann, which is, computing cellular automata, and then Feynman, which is the nanotech, and Ulam, which is on the right, the stats and the Monte Carlo method. And to me, they're at Los Alamos, so there's this nuclear in the background, and however that's going to present, like Department of Energy seems to be so central to all of this, and I have a little video that we can slot in about talking about the extension of the Manhattan Project into the Human Genome Project through the University of California. And, Jen Lake was the person who alerted me to that. But knowing that they met at Alta Ski Resort in '84, the same space that they planned out the internet in '67, '68, I think, outside of Salt Lake City, which is a center for all of this biophysics, signals intelligence, everything. And they're in Los Alamos, and they're gaming, right? It's this idea of cellular computing, gaming, statistical probability towards some sort of novel existence, some sort of novelty, is I think where it's all going. And in that context, everything that happened in California with Newsom and everything, like he's just the front man for the latest round of this. But like the UC system is totally militarized, all of this stuff. Like once you know that the Human Genome Project came out of this nuclear program and the Department of Energy is behind the Moonshot Project, that we live in a holographic reality outside of time and space by 2050, it seems like we're in some sort of crazy Netflix series. And yet all of this stuff, like with all the papers, seem to be lining up very clearly that that's the direction they're taking things. Even while nobody talks about it except for in TV series that are supposedly like fantasy.
Yeah, I also watched that movie, The Congress, the other day, and it's pretty bizarre. Yeah, living in cartoon land.
Yeah.
It's so crazy.
Disney's a big part of that. So.
Oh, yeah.
Creating a wet lab
Cool.
that is novel in every possible way. What could you create in it? You could create the future. You could create an environment of plants talking to each other with a robotic referee. And the robotic referee, and you could set an objective function, and let's say for the transaction-driven individuals in the world, let's say the objective function is carbon sequestration, and all of those plants are implemented with a gaming engine, and they have these reward system, right? And they're constantly needing to optimize the way in which they carbon sequester. We weed out the bad guys, we leave the good guys, and we end up with this like ideal ecology of carbon sequestering heroes that connect and communicate with each other. And once we have that model, this biodiversity chamber, we send it out into the field. And we see what happens in nature. And that's sort of what I'm talking about, augmenting plants with that extra dimension of bandwidth that they do not have. They're just last week, I came across a paper that discusses the in vivo neurons that are augmented with a Pong game, and in a dish they basically present sentience and the beginning of awareness, which is wonderful.
Yeah.
Like that you could actually take these neurons from a mouse brain and you have the electrical circuits and the physiological circuits that enable these cells to connect and communicate, and together arrive at sort of a swarm situation that allows them to act as a system that is not only perceived to be sentient, but is actually sentient. The system has its own rules, right? What we don't want to happen with AGI, we want to happen with synthetic biology. What we don't want to happen online and software with language, we want for it to happen with bio-based materials, because that will get us closer to growing things as opposed to assembly and mechanically, putting them together with toxic materials and compounds. So we've built creating a wet lab.
No. I mean, it's just crazy. Like, why don't you just
Yeah.
leave the cells in the mice and then they can be sentient there? You know,
Yeah.
like they're already like sentient there in the mouse brain.
Yeah, she's definitely one of the more triggering speakers for me, for sure.
Well, I mean, she must be very scripted. I mean, I think they must be giving her a story to tell, right? So we're not doing toxic compound manufacturing. We're simply creating bioreactors that we have no idea what it will do with the game engine. We put it out with nature and see what will happen, which is so irresponsible. Like, you would never like just create some random thing and then like terraform the world and have no idea what the outcome is going to be. Like, but don't worry, we're not going to use a toxic glue. We're just going to do this other thing over here. We're not calling that toxic. We're calling that creative innovation or disruptive innovation or something.
Yeah.
Yeah, and she's like, we'll just use the same 6 molecules, you know, the biologic carbon, oxygen, nitrogen, whatever that.
Yeah, I was curious
use.
about those
There's
numbers
no
because there
toxic materials.
was 100 and some she said initially, but she's like, no, now we've got it down to 6. Like, I'm curious about that.
The building blocks
well,
of
and,
life.
which is wrong too, because it's not like like life uses you know, there's like micronutrients and other things. It's not like just, you know, the vast majority is carbon, nitrogen, oxygen, and phosphorus and a couple others, but there's still like, you know, arsenic is used in molecules and sodium and all these other things. So it's not just 6, but
Yeah.
whatever.
I was trying to find.
So I think this next one that I had is around morphogenesis and the directed evolution. So again, we had the environmental templating, but then this is the electrical. So after this, then I have a short clip with Kamvar talking about cello, and then we have the Nazarov. So I think it's like a matter of scale.
Okay, is this
like
the right
from
one?
Nice, and this is a good one too, I think, because like he'll be talking about how they're on engineering the software instead of the hardware. So like with computers back in the day, in order to like program them, you had to like actually go in and solder things and whatnot. But he's saying what created the information revolution is the ability to use software to reprogram the computer, and that's what he uses that analogy for what his lab and research is doing, is that by directing the biological or the bioelectrical dynamics, is that it's reprogramming on like a software level, and that you're able to do a lot more effective work than working on like the gene scale or the you know, RNA and all that, because all DNA and RNA does is code for proteins. It's like there's a lot more going on for the larger scale assembly and creating organs and all that sort of stuff.
Well, and I would just say too, that is a really important point in, I mean, to me, if I hadn't stumbled across Levan and to understand more about the bioelectricity and embryology and morphogenesis, like this feels core. This feels like using these cybernetic energetic systems to build out a new version of what life on this planet looks like. Meanwhile, everybody's stewing around in like genetic engineering, right? Like, even think about the health freedom communities. It's all the RNA and the bioweapons and genetic engineering and the proteins and that aspect. But this is just all quietly happening in the background. And I don't think it's getting nearly as much exposure or discussion as it should have. But it is what goes hand in hand with Web3 and the templating, in my opinion. So it's, anyway, I think it's really important. So
Yeah.
I feel like there's a little bit of just like around like radiation and Wi-Fi and like high voltage cables and cell
Well, they're
towers and
concerned.
cell
They're
phones and all
concerned
that.
about
There's a
their
little bit.
they're concerned about the health aspects of it, but I don't think they have. They're thinking about it in like forced evolution or like cybernetic steering or anything like that.
Right.
Oh, and I will say too, like I haven't had a chance to revisit it, but like Stephers had an early paper where she was talking about pulsed electromagnetic frequency in the blood-brain barrier, and accessing like, I don't know if it was like nano neurotech or whatever, but like clearly the goal in coordinating humans as eusocial agents involves some sort of like, oscillation, like, entrainment, synchronicity, oscillation, like at an intellectual consciousness level, which to me, Melanie Swan clearly says the goal is to get nanobots, in your brain. And we all, do our intellectual work on the blockchain and get our micropayments from, using our unused brain cycles. But that's a non-surgical BCI. That's not Neuralink. That's something else. And there was that presentation with Marblestone and Juan Benet at Protocol Labs, where they were conjecturing on the future of non-surgical BCI and talking about pulsed ultrasound to break down the blood-brain barrier. So I do want to point that out, and that Steffers was sort of already on that track like a couple years ago. And I hadn't made that connection, but in doing the map together, I was, I was revisiting we were revisiting her pieces, figuring out where they would fit. And that was another big piece to me. That plus the Marblestone interview, like that's their goal, is the frequency to get into the structures, even though it's not, the brain isn't everything, like it is something, so okay.
Where can you find Steffer's writing these days? It seems like it's
so what, I should probably do a blog post and just link all of her titles with a hyperlink to them, because unfortunately they still exist on a piece of Mindful, but they're not easily searchable. Like they've removed
I've had trouble
her name
finding things
as a contributor. So maybe what I should just do is to make a list of them, so that I don't know if it would still be searchable on my website, but at least if you got to my website, like I've been putting them in the maps, the ones, so I have like the nanoparticle and ones about the pheromones and ones about magnetic frequency and shedding. And I put those in my maps with direct links, but probably would be good to have them all in one place. Maybe I could ask her to make a list for me.
It turns out that this is an ancient, this kind of system is evolutionarily ancient. It goes back to bacterial biofilms. Every cell in your body has ion channels. Most cells have these electrical connections. And we can do the same kind of decoding, this kind of non-neural decoding, by looking at electrical activity. This happens to be an early frog embryo. We're visualizing the electrical patterns. And again, try to decode where is it trying to get to in anatomical morphospace. And so we developed the first molecular tools to read and write these things. So here's our use of voltage-sensitive dyes to control the bioelectric patterns within embryos, to read out what all the electric communications are. Of course, we do a lot of computational modeling and simulation to understand how they connect to the channels and pumps that produce them. Beyond reading these, the kind of basically reading the mind of this morphological collective intelligence of cells, we have the ability now to write information into that as well, as people like Tanagawa do in the brain when they incept false memories into mice. So what we can do is we can take all of the tools from neuroscience, and so this is very important. The tools of neuroscience really don't distinguish between neural and non-neural cells. They all work, all the same the concepts, the laboratory techniques, the neurotransmitter machinery, like everything works. So what we can do is we can control the gap junctions, which cells talk to which other cells, and we can control the actual electrical states by opening and closing these ion channels. So remember, there are no magnets here, there are no fields, no waves, no radiations, no electrodes. We are using the native interface that cells use to program each other. There's this electrical interface on their surface that controls the information processing, and this is how cells hack each other's behavior during normal development. And also, by the way, how some parasites hack their hosts.
Fun.
Yeah, I mean, he's pretty straightforward.
Yeah, hacking behavior. I mean, yeah, that's pretty much it. Like, we don't even know there's the potential for hacking happening. I don't think it's just tadpoles, folks.
Yeah.
And I don't think
I think in different interviews that, like, so I think about 20% of drugs are ion channel, like either target or like turn off or stimulate these ion channels. So like what that company Morphoceuticals is doing is it's repurposing existing drugs which have already been approved or already on the market for these sorts of things, and then repurposing for them for this type of like electrical reprogramming, which is not, because it's more like about the chemical balances and whatnot with how the ion channel blocking drugs have been used historically.
Well, and all the heavy
I thought it
metals,
was interesting
too.
about introducing false memories. So like that's the reprogramming, but at a different scale. Like,
Yeah.
and that's part of the gap junctions, I guess, is like not knowing what's belongs inside or outside that you can kind of see.
I was collecting some clips from a discussion with Ian McGilchrist and Michael Levan and this other guy. And they were talking about, they had a whole discussion about implanting memories. It was pretty interesting. About like whether or not, like, if you plant, to have a memory, you have to have the experience to have the memory, and like how legitimate is it once it's implanted. But he was very interested, like Levan was very interested in that idea.
The gap junction is something he's really interested in. Yeah.
Yeah, he got a little bit of pushback actually from the other two speakers on that one.
Well, and I would say too, this idea of electroceuticals, that the new pharmaceutical has an electrical component, is really important, and that overlaps with a lot of the alternative medical space too, because there is a lot of interest. And again, I'm not saying that it's all necessarily problematic, but like who's programming you? Like what is these apps? What are these electrical signaling? Who's in charge of them? Do you understand how they work? That's a whole area that's going to be coming through. And
yeah,
again, for me, and this goes into like the next short clip with Cello, and then we have Nazarov, is just, I briefly sort of, and Steffers and I have talked about it early on, that like people holding crypto, it's almost like there's an energetic hold on them, like their ability to understand or think critically about the larger discussion of what this system is. And I can't tell you how many people like regularly come to me and say, well, don't you think there's some good kind of crypto? Don't you think there's some good use case for blockchain? And essentially what I respond is like, we're not in the same problem space. Like you're understanding it as money. You're understanding this as a financial transaction, which I'm not saying it's not any of that, but I'm understanding it as a signal that links that superstructure to biophysics and social physics. And I know that for me, and speculation and derivatives and risk management. And to me, like I can never disconnect what it might be on the top as your freedom money from that. But for the most part, people aren't entering into those other spaces. They're simply working in one narrow problem space and they're not willing to consider. And I feel like there might even be some energetic, like not exactly an electroceutical, but like, is there a cognitive that comes with like having a digital wallet with certain tokens in it that like energetically in your psyche, I don't know, like that's totally speculative, but there are these weird overlaps between how your biology works. And then again, if our brain is a quantum computer, or if not just our brain, are the cytoskeleton microtubules and our cytoskeleton are quantum. Like maybe there is some sort of entanglement when you get entangled into these financial systems, that there's an ability to control how we understand. I mean, they literally talk about false memories. Like maybe there are other ways of controlling how you understand the world. And that's why we're just having such a hard time getting through to people. I don't know.
Well, it's there's something symbolic about it. Like you own this thing. Like it's like, oh, this is something that I have. I own this, even though it's just fake. Yeah. It's just digital. It's like pledging allegiance to the flag or something. It's not real. But there's a psychic connection that's made there for sure.
Definitely.
And the other thing about Cello is that. Okay, sorry. Oh.
That's the delay. Sorry about the. Just a little side note is that I think in 2017, maybe a little bit earlier, I was looking at all of Levan's papers, and one of them was on ivermectin and I believe chick embryos, and and the essentially how whatever ivermectin did to the ion channels and that sort of thing. And that just was kind of funny because it was before, it was pre-COVID and all that. And it's just kind of like
wow.
but yeah, it was just a
But
funny.
there's definitely a reason they want ivermectin in people. Like, and I have friends looking that up. So I don't know if you still have that link, I would be interested.
Yeah, that would be
forwarding
interesting.
that to people who are,
Yeah, I can
like,
find
or maybe
it.
just Google it.
Yeah,
but
within the
Yeah,
resistance that was been pushy. I mean, I know people that are like, "Hey, I got some if you need some or whatever," and I was like, "I'm good." But yeah, people like swear by that stuff.
Well, and then so this image, this is, you can see behind him, is in Barcelona. So, and if we're thinking about electrical communication, again, graphene is part of that electrical material. Like, it's a material that's
Yeah,
part
it's very
of,
highly conductive.
highly conductive, and Barcelona is a center for graphene like production. And then you see the image that's connected, right? Like, that would be sort of the wood wide web, right? He's got a forest and the light coming in through the forest. And so that's sort of the implication is to me, the fungal network and the interconnectedness of, like, they want very much for this digital system to be equated with a natural system. They want to sort of, to me, take bio-inspired design and almost take it over, right? Like, we're better than nature because, like, we're not second to nature, we're inspired, and therefore we're even, like, superior by incorporating all of the great qualities of nature into our engineering. So, but again, this is for Cello. So this is the digital money often tied to humanitarian aid or microfinance. And I'm trying to remember the name Cello. It actually, what is the language that's supposed to be like a universal language that never took off? I'm trying, like, the Baha'i are kind of all kind of.
I just read the word
like
a week
Cello
ago.
is like that language. Like, I can't remember exactly what it means, balance or something like that, but like, it is part of, and I think this idea of a universal language, and a universal language of whether it's chemistry or energy or molecules or life, it does feel kind of like it's linked into that whole tower, Babylon, and the language getting back to a universal. So I feel like that's significant. So anyway, this one's pretty short.
Yeah, well, there's an app, Babel, for translation, Babel app. Okay.
Oh, yeah.
And also Charles Eisenstein, just a reminder, Charles Eisenstein is an advisor to Cello.
Don't worry, it's sacred. Your sacred digital money.
You can tell I've got kind of a beef with Charles there. All right.
It's two sides of the same coin. A UBI is like rain, it ensures universal health, and demurrage is like evaporation, it ensures non-stagnation. The third feature is a feature called natural capital-backed currencies. And this is an idea by the philosopher Charles Eisenstein, who said, whatever backs money, people tend to make more of. When gold backed money, there was this intense incentive to mine gold because it was like printing money. In ancient cultures where cattle backed money, there was an overproduction of cattle because that was printing money. And so he said, well, why don't we back money with things that we want to see more of in the world, like pristine forests or clean rivers? And that's a beautiful idea, it's a powerful idea. And that's the third feature called natural capital-backed currencies.
Great.
Natural capital-backed currencies. So now we have Nazarov. Oh, shoot.
No, I've got Nazarov next. We're next.
Okay, yeah. I think Nazarov. Yeah. So Leo, do you want to mention is the segue to natural?
Yeah. So this that's pretty much precisely what's going on here. So the guy on the right. Sorry, I got a right and left mixed up for a second there. I actually forget his name, but he's the head of banking services for the BZN Bank in Australia, which I think is one of the 4 big banks in Australia. And what he will describe is basically an ecological credit system for its cattle and ranching best practices. So basically credits for using less fertilizer and better regenerative cattle practices and stuff because of the runoff into the Great Barrier Reef, which has been causing like the bleaching and the dying of that giant coral reef there. So yeah, he's explained this, and it's a good example of not a carbon credit but an ecological credit, and the types of things that Celo is focused on building, and it's a major bank. And yeah.
Okay.
Well, I mean, the reef credit is a uniquely Australian nature-based asset addressing needs of the Great Barrier Reef. Of course, hopefully most of you know what that is. The largest reef on the planet, and it is getting bleached and also impacted by nitrogen, which runs off of farms because of fertiliser in Queensland is used for farming and land management. So the reef credit is an incentive, a financial incentive for farmers and land managers to change their practices, reduce the amount of nitrogen, reduce the amount of runoff from their properties that eventually find their way into the ocean and impact the reef. So that financial incentive is supported by the Queensland government, and they run the registry. So what we've done is taken the credits that are being produced by the folks that are doing much better work around their land management. That goes onto a registry, and we can take the credentials of the project and put it on the token, right? And so in that way, you're actually differentiating the tokens to the extent you're actually creating an NFT as well. So we use a different standard to create that NFT because the credentials of the project give the buyer the look through right to where the land management practices are occurring. Same with carbon. We can do the same with carbon credits as well. So then you take that and you put it on a blockchain and say, we have a token for sale. And then we have, on the buy side, we've got one of our customers, Grollo Carbon Ventures, wanted to experiment with improved operating models for acquiring nature-based assets. So they bought, and not in this case, but they bought Carbon Office in the same way. We tokenized carbon, and they purchased that on-chain with our $8 With this, we haven't revealed the customers yet. That'll be soon, and some press we're going to be doing. But same story. We have customers who want to own these credits. This is not an offsetting credit, but it's one where the company involved, when you hear about it, you'll see, that makes sense for their kind of corporate brand and the way they want to do business. They're a retail brand with a lot of association with the sea, and they wanted to have the ability to project their green credentials, but also give their customers these credits. The great thing about tokens, as you know, Sergey, you can fractionalize them right down to tiny amounts. So the idea that a brand could purchase tokenized reef credits and say, you buy a pair of some of our goods, and we'll give you some reef credits. And then as a bank, we're saying, well, we think that not too far away, that digital wallet's going to be the stable mate for bank accounts, right? So we want to facilitate that capability so that when we do have customers who want to either give or gift or trade with nature-based assets that we've tokenized, they can hold them as offset to retire, or they can give them to their customers.
So one thing is the fractional nature of tokenized assets and how low that can go in impacting the consumer and how shareable that is, all the way down to even the average consumer. So that's a very interesting aspect of tokenized assets that I feel is underexplored. Beyond being the leader in blockchain technology, I do also see you folks taking a real leadership position in green finance and those things. So why do you think that blockchains and tokenization have a role to play in that industry generally?
Yeah, well, again, it's very complementary with our sustainable finance strategy, firstly and foremost, but secondly, it allows a substantial uplift to the operating model of green finance, particularly credits, carbon credits and offsets today, which are basically still, at least in Australia, still traded on the phone over the counter. So it really is, it's decades old technology, it's slow, it's T+3 at best, and it's really clunky. So the ability to leapfrog straight to the most contemporary type of financial market infrastructure for an asset class we care deeply about, that we have invested in, is really exciting for us. What about you? What do you think is going to happen in the future you've talked a big story today. I think it's something we've definitely bought into. But what do you think 5 to 10 years from now, what a digital asset market's going to be looking like for this audience?
I mean, it's pretty simple for me. Every bank's going to have its own chain. Every bank's going to have its own stable coin. And every bank is going to have hundreds of real-world assets that they take from the real world and they package into tokenized blockchain things. There was this word securitization.
Yes.
Securitization is not a popular word anymore. But the logic of securitization makes a lot of sense, right? People want exposure to other assets, the cash flows, to other categories of economic activity that they can't get access to, period. And they want that easily purchasable, easily holdable, easily transferable, and in deeply liquid markets where they can resell it easily.
Yeah. So they're getting to, there's a lot there. So I'd say like on the first step, I feel like the connection between the nature-based assets and the branding, the marketing, and the like retail use of tokens as sort of like an evolved organic certification kind of, or non-GMO and that sort of thing.
Yeah.
I think that's going to be pretty important, and that fits into a lot of like what you're doing, Alison, with the kind of storytelling or narrative aspects of these sorts of things, and getting the storytelling games into it and all that sort of thing.
And it's a signal,
then
like down to the
it's a
consumer.
signal, right?
Like, so then you can track,
Right.
and then you can compute on those signals of where the flows of the credits go.
Well, and for the investors, they just want to make money, but they're not necessarily conscious of the game necessarily. They're going to know the game in terms of how do I play it, how do I make enough money, but they're not really writing the rules of the game. And I think that's the point, is just that there's this undergird structure that's where the steering comes into play. But in terms of just the average person that's going to invest in these tokens, they're not necessarily
Sounds
trying
good.
to. Yeah.
Like, I mean, if you trusted that, like, derivative, like, I can't remember if I included that, but he was like, yeah, securitization kind of has a bad name lately.
Yeah,
but,
he said that.
Yeah,
It's
that's
like,
at the end.
But the idea is good. It's just
we
we don't want to call it that, because people know what it means. But that's my whole thing. It's like everyone that's all wrapped up in this Marxist understanding of the world, like, oh, late stage capitalism and all this other stuff. It's like, no, like it's dematerialized capitalism. And other things. It's not just capital. Obviously, we've had these conversations. It's not just that, but it's like you can create markets out of like anything at this point. It's just like the sky's the limit with these NFTs and tokens, and you can split them up.
With the like the best practices, instead of this being like a carbon credit thing, I think that's important, and that's how a lot of this is really being implemented, which gives it requires the type of data collection and monitoring of the farms and all the inputs and all that sort of thing, and having that computable, like you said, all those credentials going straight onto the token itself. But you see in the US, and I think I brought this up in in the recent articles about, so the USDA has I forget the number, it was at least $1 billion program for smart commodities. And if you look at a lot of the projects, it's very much in this sort of realm about incentivizing best practices for cattle or for certain crops and all these sorts of different things. And there's another group called the Ecosystem Services Market Consortium that's funded by an organization that's funded by the federal government through the 2017 Ag Bill, but that is very similar. So about quantifying how certain practices increase values like organic matter in the soil and carbon sequestration by the soil, and decreased runoff and these sorts of things. And it's also happens to be, that organization happens to be funded by like Nestle and Bayer, which is Monsanto, and some like the largest like Cargill. And, like, it's like a pretty funny, but
yeah, real funny.
Yeah, so basically that, funny is probably not the right word, but yeah, that, and there's and like, you know, you look at it and it's like, yeah, I mean, obviously we want cattle farming and stuff to do better. Like, you know, there's a lot of issues with how conventional agriculture works, and it's really cruel and poisoning, you know, us and the animals in a lot of different ways. So it's like kind of hard to talk about some of these things sometimes, because it's like, yeah, you want
Right.
farmers to be compensated
You
for
know, dance
doing things
compost.
that are, yeah. Yeah, exactly. Like, who's against compost? But
Possibly the human composting thing. I'm not so sure about all of that. Yeah.
oh yeah, right. That's fair. But
Well, there's a history too of
yeah,
like
but
incentivizing farmers with aid. You know, like that was what it was. That's how we. That was the Green Revolution. That's how we got where we're at.
Right.
Was this
Yeah,
exact same
totally.
thing? It's just now they say, oh, now it's good. They said that back then. They said this is going to increase
this is
your
the better way
yields.
to do
This
it.
is this is, and it's the same institution, same companies, the same players that are doing this. So I'm kind of stunned
not
that
the same.
anybody that's a genuine environmentalist, or, you know, someone that's really genuinely cares about permaculture and healthier ways to do things, that I'm just kind of stunned that they would actually buy into this, you know. But
yeah, I'm not really, because it's like, you know, once groups that have been trying for a really long time to like get their ideas and voices heard about how to do certain things, like how to do regenerative grazing or whatnot, and then suddenly the USDA and all these other institutions are willing to fund them, and it's like, oh, but you know, as long as you collect the data and get the cows on their GPS tracking and geofence and all this sort of thing, and do the tests necessary to get all the information, then yeah, you'll get the payments, and we'll promote that and create new branding opportunities and all this sort of thing.
yeah,
I have to say, like, listening to the Soleil talk about Neumann and plants and computation, like, it makes me think a little bit differently about the whole like crop insurance and plants in warehouses, and like the aeroponics and hydroponics, and like moving plants into controlled environments. And, you know, again, we already know that, you know, they were talking about growing, you know, vaccines in tomatoes or lettuce or different things. Like they're already using plants computationally as fabrication units.
yeah.
I don't know. Like I have a hard time wrapping my head around what it might look like, but with that theme, like having that like additional lens on it, like I starting to look at like industrial interior warehouse agriculture in a way that may have computational aspects. It's interesting to think about.
Absolutely.
Certainly possible.
Yeah.
Oh, and I think it's also worth, like, for Chainlink too, because they sort of talked about it, but it wasn't clear. So Chainlink recently, and Jason brought this up, I feel like you brought it to our attention, I don't know, like a month ago. It's pretty recent, the CCIP, so the Chainlink Cross-Chain Interoperability Protocol, which is basically a system for being all different blockchains, like including public, and I think even off-chain too, like legacy financial software and that sort of thing, but creating like an interoperability network, that, because it's like in the crypto space, there's sort of like there's these bridges which are generally like centralized connections between different blockchains that have been like historically vulnerable to attack. It's like one of the, you know, I think it's like billions a year generally gets hacked out of these cross-chain bridges. So like interoperability, I mean, for, you know, for pretty much the whole existence of blockchain, interoperability has been something that they've been working on, but it does appear that with Chainlink's like pretty unique position as being an oracle network for most of these different chains, and having that sort of system already in place, which is basically like a system that allows like price feeds and information to go from off chain onto chains. So like information about, I mean, primarily prices, like prices of assets and other crypto assets and stuff for financial applications. But they've made this like larger system for actual interoperability of transactions and like money flow and stuff, and had a big partnership with Swift and all these different banks like BNY Mellon and
Well, they've positioned themselves to be, I mean, if they succeed at what they're doing, which I think they do, I think that this is all planned out. They're meant to be that layer. Yeah. But they're going to be, I mean, like how many people have heard of Chainlink? Hardly anybody. No, they're going to be one of the most significant corporations in the entire world, because they're going to be centered. They're going to be centered at the center of all of these coins. They're the ones that everything goes through. Now, I don't think they're going to be the only ones, but I think they're going to be probably the most significant one. And so that's huge. So when I saw the thing on CCIP, I was like, oh, this is huge. This is the thing that links all this stuff and could even link it with the BIS and, can link it with like, this is the thing that could link all this stuff together. Because before it was like everybody's having these, and I can't remember who it was, if it was Polygon or one of the chains is a second layer. And now they're about to switch to being first. They're about to switch over to, I'm sorry, they were a layer 1 and now they're going to switch to being a layer 2 part of Ethereum. So they're merging. One of the major, I have to find it. I just watched it the other day. It was on CoinDesk.
Arbitrum?
Excuse me.
No,
it wasn't. It wasn't it, but it was there's one of the. Yeah, it was a really major one, but I was like, oh, I was kind of taken aback when they said that because it was they were their own chain, but now they're. So I think a lot of these things are built separately, and then at a certain point they link them up, and I think that's what the CCIP thing is. It's like, okay, now it's all connecting together because people are think they're ours isn't that, we're not that. Anyway. But the Chainlink YouTube channel is worth like looking at, especially some of the latest talks on CCIP, because I think that is a really important technology that's and he's connected with, he's done talks with Eric Schmidt and a bunch of different people, so he's like, it's a big deal.
Well, I was just wondering too if
you go, Alison.
Oh, sorry. The tokens that it seems like what they're after is some sort of universal coordinating signal that could be imagined as a language. Like if the thing is like after Babylon and everybody broke up into all their languages and we're seeking a universal language, if that's the Leibniz, this language, and that likely it will be a computational language, right? It won't be like this, and this language bridges economics, it bridges biology, it bridges the psyche. That it just struck me when what he said was in the token you can look through to like the place where the activity was happening, and to me that's like a nested story. Like the token then becomes a nested story of complex information that could be rendered digitally and accessible in any language around the world through an oracle.
Yeah.
Like that may, and I actually have to credit, I think my friend Sean in Washington, like he was talking about minting coins and minting piece metals that are traded with indigenous people, and like the imprinting of that and the importance of the Philadelphia Mint. And like, you have an image, but the image conveys a story, like an archetypal story that's more than the strict image that's on it. Like it has depth. There's the image, but the image embodies something more complex than just the surface of that. And to me, and even Jason, like when you were talking about Levan and those things and the chimeras looking like tokens, that is this dynamic language that could be, I don't know if that makes sense, but I'm just wondering if that's what they're after. If the token exchange signaling that can render complex stories across dimensions, like across time.
But it also ties, I think, in with. I think it also ties in with like knowledge management too, because if someone might hear a universal language and they think, oh, we're all going to be speaking the same language. No. You can still have your culture. You can still have your own language. You can still have your own community, and there can be an infinite number of those things. But what you have, it's you have the universal language is what connects them all, and to a particular to the machine or to whomever is granted access to that layer. That's where that management happens. But you could be thinking, living in your own little bubble, thinking that you're like doing you're in your freedom cell or whatever, thinking that you're like, doing your own thing and not even having any comprehension how you're fitting into this larger thing through the universal language or
actually somebody sent me a link to like Derek's doing some pitch on his crypto program, and think about it. It's called the conscious resistance. Because to me, like a deeper than the economic transaction, which is vitally imperative, and that's the space I lived in for a long time, I feel like the consciousness, like collective consciousness, is actually the next level. And I know it's a little bit harder to pin down, like this panpsychism, animism type thing, but to me, it's like the why. I don't think the why is just we want to make a lot of money. Yeah. I think the why is that we want a coordinating signal that we can tap into the collective complexity and unexpected random nature of life itself, interconnected life itself on this planet, and use it for some tool. And in that, this token language would be a key part of that accessing that consciousness.
Well, yeah, I'd go to a crypto event, and like all the people there won't be thinking about what you just said. Like this is some sort of like larger thing. To them, it is just about like, oh, I'm going to invest this token and I'm going to get more. They're thinking about it on they're on this layer, and that's all they see is their layer. But it's pretty clear. Like I've always struggled with this too, and we've had conversations, Alison, about like, why, what's this for? Like, even though I know, like they even openly say like, this evolutionary advancement and, this coordinating everything towards what and why, it's a mystery to me. And I honestly, genuinely don't know, but I can't deny that it's happening because you see all these things that like totally line up, and you see all the language, and you see, you can see it happening even if you don't know necessarily why or what the end game is. You don't necessarily need to know that to see that it's happening, and most of the agents in the game, even at the high levels, probably don't understand what it's for. I mean, that's what it appears to me.
Esperanto, that's the language. Oh. And that's why Cello is Esperanto. Leo, that's why it's Esperanto.
Yeah.
We're right. I think we're right.
So what is
Esperanto? I think so.
What is Cello within Esperanto?
Yeah, it is Esperanto.
What is Cello within?
But I think that what is the? It's. I mean, I know they say Cello.
Let's see.
Cellophane.
Cello. Sorry. My goal or target. Aim, objective.
Oh, that makes sense.
Yeah. Wow.
That makes total sense.
I guess we got it, guys. This is pretty amazing.
Yeah, because when I first we were thinking like cello, like you're playing a musical instrument, but that makes sense.
Yeah. So what's spoken language?
Yeah, and I can tell you the goal is not to make a healthier ecology.
Flourishing. We're all gonna flourish. Damn it, Jason.
Flourish in the forest.
But not for the synthetic bee apiary, because there's no flowers there. There's no flourishing in the synthetic bee apiary.
Yeah. but you can
I
imagine
think we're
them.
near the end. We have just a couple more.
Yeah,
Should we
we've
slog
yeah
through?
yeah we've got a few more here. Let's.
I want to do the two-headed planaria. Like, because again, this is like going
Let's do
back
it.
to the electric, the biology, like height. And I want to again credit Steffers on this, because we were talking earlier on about steganography and like hiding information in pictures. So there's encryption, which is a different kind of thing, but steganography is like visual imprinting. And again, her sort of superpower is looking at digital media for imprinted information that's like not hidden if you know how to look at it, right? But it's for the general public, you wouldn't notice it as anything out of the ordinary, but for people with it. And then there's a whole way of digital steganography, which is hiding information within pictures. That's its own encryption, like type of thing. But within that idea, in this clip, Levan talks about how he can recode planaria to have two heads, which is really messed up, but that they could do that to a planaria and have an embedded code in a one-headed planaria that if it were injured, if it had a disaster or shock trauma, that it would get two heads. And so essentially it's a hidden code system within the biology of the planaria that becomes activated upon a trauma being inflicted on it. And then the plan B comes up, the game B comes up. And so I'm just going to pause it, like think about it when you listen to it. If energetically, if you could have that on a societal level. So they're saying the body of the planaria has two patterns of itself, the one-headed version and the two-headed version. And the two-headed version only comes out after part of it's cut off, and then it comes back. As
or the head explodes like the other one from the.
Yeah, I don't know if that would trigger it in the same way,
No.
but imagine if it were at a social level, that if you could, with your universal language cello coin, hide like an optimization goal for society, that there were two parallel, one that was active and that one that was subliminal. And upon a certain trauma being inflicted, the subliminal one would arise to the surface. Right? And so
You're going to find out, Alison, that you're going to find out you're still on Facebook pretty soon here. You're still active.
But no, I mean, here's what I'm wondering is, like, there were so many strange things that happened when the lockdown first happened, like things that didn't make sense, like people who you couldn't have a logical conversation. Like it was literally impossible to have certain conversations. And it didn't really make sense because it was literally like one of the game mechanics that I was reading a white paper about. They were talking about essentially learned helplessness within a game where you were engaging with characters and there was nothing that you could do that would give you any agency. Like you would keep trying to enact your agency with other characters in the game, and it was not effective in any way, which is what felt like that to us. I didn't have the language for it at the time, but looking back, I'm like, no, that was that. And so you keep trying to affect your agency and have the conversations. It keeps not happening. And I'm wondering if, like this weird planaria thing, if you scaled it up to a social level, there was a shock trauma that activated an imprinted concept of what an optimal society looked like. And somehow there were some of us that didn't get a firm imprinting. Like the 17% of us, it didn't take. Like we didn't have the second optimal biological signature. So we just never got there. So anyway, I know that maybe that's a bit far reaching, but I did just nail cello and the, Tower of Babel and the universal computational language of optimization. So just think about it.
No, well, just based on my experiences, that doesn't seem far-fetched to me. So.
Yeah, no, not at all.
All right.
There's other weird things going.
Oh, what's that?
Oh, no, just there's other like things not even relating to that whole situation that felt weird at that time. But like personal things that I won't get into. But it's not. Yeah, that didn't really have to do with.
Yeah, well, I'm still experiencing it with people it's like you can't. There's
like a force field.
Yeah, it's literally like programming. It's crazy. Okay.
But what they're saying is they can put in false memories. They can they can program electrically, and they're working at like pulse EMF, and like we go all the way back to Vannevar Bush and Raytheon, right? And Howard Hughes and Hughes Industries and lasers and all of this stuff. So like maybe these directed energy weapons aren't just like we want to zap you, burn down your forest with a laser, but we have all other kinds of pulsing, other kinds of. Okay, planetary.
Okay. All right.
Yeah.
If you cut them in half, the bottom end grows a tail, the top end grows a head. But these cells that you just separated were next door neighbors before you cut them. How come they have completely different anatomical fates? That question cannot be answered locally. You can't tell from where you are what you should build. You have to communicate with the rest of the body and figure out what's missing. So this is non-local decision making. So we asked this question: when you amputate this planarian, how do you know how many heads you're supposed to have? And it turns out that there's an electrical gradient that we characterize that tells you how many heads you're supposed to have. And if you and what you can do is you cut off the head and the tail, and this middle fragment will regrow a nice perfect worm 100% of the time. But because we understood this gradient, we were actually able to make these two-headed worms by taking this electrical. So here it says one head. But now we can say, no, actually you should have two heads. And sure enough, this isn't Photoshop. These are real animals. They make nice two-headed forms. Now, here's the really important part. This bioelectric map is not a map of this two-headed creature. This bioelectric map is a map of this one-headed creature. So what we did was we rewrote the stable bioelectrical pattern memory in this one-headed animal, and it stays one-headed with a normal gene expression. So here, anterior genes only in the head, not in the tail. And it sits there perfectly happy like this until it's injured. So a single planarian body is able to store at least two different representations, two different ideas of what a correct planarian looks like, and sit there, and it's a latent memory. It doesn't do anything until you injure the animal. The same body, the same one-headed body, can store two different representations. So at the very beginning, I told you that this collective intelligence works towards, it's a homeostatic loop that works towards a specific set point. And the question was, how do you store a set point for anatomy? This is it. You are literally looking at an example of how of how pattern memories are stored. They're stored as a stable bioelectrical state in tissue. And it's this in particular is kind of cool. It's a counterfactual memory because this is not a representation of what's happening now. It's a representation of what you're going to do in the future if you get injured. This is memory. It's long-term stable. It's rewritable. It has conditional recall, as I just showed you, or latency, and it has discrete behaviors. So what we're doing is we're reading and writing patterns into the collective intelligence of these cells that must navigate anatomical space. And so now what that means is that we can really do the kind of computational work of fleshing out the connections between the electrical state space of the circuit that we understand with all kinds of ideas from connectionist computational neuroscience to understand how electrical networks can store patterns, do pattern completion, and navigate spaces intelligently.
How did I get here? This is not my beautiful head. But
if you imagine like hidden patterns in a cellular collective in which people are agents and the collective is a society, like you could think about Cello, think about digital money. You could encode secretly patterns that could then be activated upon some sort of chemosensory environmental sensor signal.
When you can have reinforcement too between, because traditionally, those of us who study like media culture, we're looking at like propaganda, like, oh, how does propaganda work, and then you're like, oh, then some of us
propaganda when you can just program your brain, right?
Right. Well, this is like next level. It's like, oh, they can program. Well, they can use tokens to program you. Oh, wait, no, they can actually just speak directly to your cell and tell it what to do. So that you're going to have like a mutiny. Your cells are going to have a mutiny. So twisted. Sign me up. I don't know about you guys, but I'm ready. Let's do this.
I mean, people
Leo?
don't have any idea. Like my family, I'm just so sad. They think I'm really crazy. And I'm like, no, we're not crazy for saying, wait a minute, Michael, stop it with your electrical programming.
Can we do a moratorium here?
Yeah, it's like I'm kind of fading, but it's
All right. Well, this is just the last one.
It's pretty insane.
So you want to do this other
Can
Michael?
I just do the last, like the Gaia, mind everywhere, like the panpsychism. Oh, you want to do like the mind, the butterfly one, the metamorphosis, the butterfly? Because I thought
we can do that.
Oh yeah, that one's crazy.
So to me, this is kind of the most interesting. Like when he's talking about the embodiment, because I think what we're about is embodied intelligence. Like there's something about our body, like being an embodiment. Like they can't do what they want to do with virtual avatars, even if they somehow put the complexity of a human mind in a mind file and ran it around in the internet. They can't. It's like, I think there's something about, I don't know if it's resonant crystalline nature of how we operate with each other and our electrical signaling with our heart chakra and our brain. Like there's something about the body that's important. I'm not saying that we're only body or that that's all there is, but for the embodiment, this collective computation needs a body. But there is some interface between consciousness being out there and the body, like how the two interact. And so to me, the fact that Levan is bringing up the whole butterfly metamorphosis, and then how do the memories of the caterpillar, even though they're totally go to mush in the cocoon and then come out as a butterfly and it still has the same memory, that implies that he's thinking on those lines, like where is mind? And then how does the body work with the mind when they may not be totally congruent all the time? And he's clearly a super smart guy. So like this whole panpsychism thing and animist world thing and whatever, like this to me is kind of the interesting opening, because it's not as like clinical as like, okay, we're going to use our whatever, ion channels and do the head programming. Like this is a little bit higher level, but the implications are kind of profound as I see it, especially if you go back to like Bernal and his crystallography and thinking about us like that. So
yeah, okay.
I don't know.
Yeah,
This caterpillar.
You see the first. So you can see the first point. Minds are embodied.
Yeah.
So yep.
And they can change and be remapped. So.
This caterpillar is a soft-bodied kind of construction. It needs to turn into something quite different, which is this hard-bodied machine that flies around and it drinks nectar, and it has all sorts of different behaviors. It lives in a three-dimensional world. In order to get from here to here, this creature basically deconstructs its brain. This brain is taken apart. Most of the cells are killed off. The connections are broken. It creates a new brain that's suitable for driving this kind of body. Something very, very critical here is that it's been found that, you can read about it here, this is all the work of Doug Blackiston, that caterpillars that are trained to associate feeding with a specific stimulus, that memory persists. So the butterfly still remember and can be tested behaviorally to show that they can still remember. So here are a few remarkable things. First, that memory survives basically the deconstruction of the brain. We don't have any computer architectures that work like that. So how does the memory even survive? So that's the first thing. Is why I don't think we understand very much about how memory is stored at all. The second interesting thing is that the memory is generalized and transformed because butterflies and caterpillars don't eat the same things. So butterflies drink nectar, caterpillars eat leaves. So you cannot simply learn that stimulus associates with the presence of leaves, because that will not serve the butterfly at all. That memory has to be converted and generalized into the idea of food, not leaves, but the generic concept of food, so that the butterfly can now can make use of that memory and acquire food that's completely different from anything the caterpillar ever saw. And what's happening here is that these memories are being remapped onto a new architecture, not just in the sense of driving a different body, but in the sense of having actually novel generalized meanings. And then finally, you can ask yourself this philosophical question, with Thomas Nagel asked, what's it like to be a bat? Well, the second order question is, what's it like to be a caterpillar slowly changing into a butterfly? not on an evolutionary timescale, but on the timescale of a single organism. What is this transformation like? What's the experience like?
And see, I sort of think about that in relation to the blockchain mind files in Hanson Robotics and OpenCog. And like, what if they're imagining it in this guided evolutionary process towards some sort of eusocial swarm intelligence, that by being agents in a game, that we will somehow have an architecture that our consciousness gets put into this new embodied form. Like, I'm not saying it would work that way, because I think whatever we have, like, we're already embodied and there's a process that we go through, and that, you know, we're born and we have this life, and then we pass into some other dimension, and then what happens next happens next. And I don't think that's just the end. And that's a natural process. But I think that the system is seeking to transmit us into a more controllable cybernetic system, that they might be like to tell us the story that we're going to metamorphose into the Operation Moonshot mind file, where we can just occupy the body of a Sophia the robot, or I don't know if they've come up with a guy robot yet. Do they have a guy? They have a guy robot. I don't know his name. But anyway, or trans or whatever, like whoever the other robots are, that you pop over into. I guess you don't even have to be a person. You could be in our Boston Dynamics robot dog or something.
Yeah, you could be a chicken.
Go in outer space. So,
a chicken
anyway,
bot.
Maybe that's a weird thing to end on, but I feel like that some of this digital agent stuff is moving into the like. And again, the whole silkworm, when she's talking, Oxman is talking about the, you know, she did several big projects with these silkworms. And then Levan's like, well, not Levan, Friedman's like, well, don't you think, can we engineer the silkworms and make them, or there was a proposal, a different proposal by another scientist. Maybe you can make them glow in the light, which was weird because you would think glow in the dark, but glow in the light. And she's like, no, we cannot genetically modify the silkworms. But we could modify bacteria, because I don't really like the bacteria, but not the silkworms. And the silkworms are themselves a metamorphic creature. And then the silkworms have this whole, is it sericulture, like silk culture, like in China. And so some of this whole morphogenesis feels a lot like Kundalini, energy medicine, all of this stuff. Like maybe there's something archetypal about the silkworm. She's like, no, protect the silkworm.
Save
bacteria
the silkworm. I'm going to
like the hexagram and the I Ching or whatever. There's something strange about that exchange. I don't know, Leo, if you caught any of that, but like the energetic exchange about the conversation about the difference, there was no logical reason for it. But it seems symbolically that silk and China and like this history of like, I don't know, there's something about that.
No, I didn't actually catch that part. That's,
You have to revisit it. Well, all
right. Well, thank you guys for hanging out with me.
There's a few more, like maybe we could do another one of these down the road and add some of this other stuff.
Definitely.
I think we covered like a lot.
His engineering.
Yeah, that was
think how far we've come since like the Internet of Agreements and smart contracts. I feel like it's gone a little bit off the rails.
It's kind of overwhelming, but you know, like it's definitely interesting, and it's real. I mean, it's like
it's definitely real.
It's you know what I mean? Like people are really doing this, so it's like, and it's relevant. It's true. It's relevant. It's happening. Like, you know, so yeah.
I think the whole like complexity, the shift in the complexity and cellular computation, like that's the next phase. Is linking the economic, the econophysics, which is really what the Santa Fe Institute, like they pioneered econophysics. And their backing was from Citigroup. The guy was from, but they're moving into biophysics. So, and then social, you know, like, so that whole Manhattan project, Los Alamos into Santa Fe complexity game engines.
Feels like a metamorphic. They wouldn't connect these things at all. They would never think that there's a connection between any of this. Yeah. And I think that's how
we all talked at once.
Like everybody's talking about Epstein, but they don't really talk about Santa Fe Institute that much. Like they don't, or if anything, I had a guy like who I thought understood what I was talking about. And he was like, oh, I've been following Santa Fe Institute for a long time. And I'm like, oh really? Like almost like he thought it was a good thing. And again, I'm not trying to say these are evil people. Like, that's not helpful. I kind of had a whole shtick, but I'm like, when you understand the historical context, I don't think you could just see the power structure as neutral or like as benevolent.
Right.
Because they're not being open.
Yeah, it's not just interesting ideas.
Yeah.
Hey, question. Do you guys can we do 2 more minutes? I just want to end on one quick thing. As I really wanted to share this one clip because the way she says this whole thing of like the human, well, I'll just let her do it. It's only 2 minutes.
And that's so fascinating.
Let her have the last word.
What?
We're giving her the last word.
we'll be like phooey or something. We'll end it with that.
Yeah. And that's so fascinating because, these are not the stochastic parrots. This is sort of a new form of emergence, perhaps, of novelty, as you say, that exists by virtue of using old things to create new things. But it's not as if the AGI has self-awareness, right? It's not as if it has, maybe it has, but as far as I can tell, it's not as if AGI has approached consciousness or sentience just yet. It's probably getting there, but the language appears to present itself as if there is sentience there, but it doesn't. But I think that's the problem, at the point where this AGI sounds like me and speaks like me and behaves like me and feels like me and breathes like me, and my daughter knows the AGI to be me is sort of the end of everything, right? Is the end of human agency. But what is the end of human agency to humans, I think, is the beginning of agency to nature. Because if you take all of this agency, if you take all of these language models that can summarize all of human civilization and consciousness, and then upload that to nature and have nature now deal with that world of consciousness that it never had access to. So maybe through Eliezer's lens, the sort of short-lived human becomes sort of a very long-lived human-like sentient weeping willow. Maybe that's the end and the beginning. And maybe on the more optimistic side, for us humans, it's a different form of existence where everything we create and everything we consume and everything we process is all made up of 6 elements, and that's it. And there's only those 6 elements and not 118 elements. And it's all the stuff of biology plus some, fair amount of bits, genes, and atoms.
Well, I think the idea...
A lot of Beethoven.
So I thought that'd be it's an end on, but that whole thing of like human agency is going away, and nature's agency is going to come forward through this smart technology, through their
Green New Deal.
Yeah, the green, right? So, but and there are people that like really would feel, I would, like we need to like it's nature's time now. So I could see that people would actually endorse that, but it's not even what she's saying it is anyways. It's what it's putting this digital layer on nature to dominate it in its own way anyway.
Yeah.
So yeah, I wanted to share that one.
Well, and the post-Anthropocene is a huge narrative structure, like talking about like we need to be done with humans. Like the human stuff is over. Now it's the next thing. It's not nature. I mean, what they're talking about isn't natural. I mean, in fact, how would she say the elements go away? I mean, if it's nature, if it's Bernodsky and biogeochemistry, they don't just disappear.
Well, it's like your appendix, Alison. You don't need it. It's just take it out. Take it out.
But it's like nature doesn't have all those other elements anymore. We've just decided we've narrowed it down, and that's we're giving nature only 6. I don't know. It's weird.
Well, and there's another there's another clip where she talks about humility. We need to have humility, which was hilarious, considering who it was coming from. But anyways, well, thank you guys.
Well,
I think
thanks,
go ahead,
Leo. Jason,
go ahead.
hosting.
Yeah, thank you guys very much. I feel like we covered a lot. I feel like I learned a lot. and it's good. I feel like that was pretty like what we set out to do on this conversation, and I think that's gives people a fair amount to chew on, and even if it's only like a couple other people, it's fine. And
it's the butterfly effect.
Thank you.
Well, I can say I'm in this process just along with anybody else that's maybe watching. I mean, I'm learning as I go along. Like I'm not an expert on this stuff. I'm just figuring it out. So's Alison, so's Leo. So, join us.